Hello. Hello. Yes, hello everyone. Welcome on Yourpedia platform. So guys, we are meeting after a long time. I hope you all are fine, preparing well. So anyone please confirm my sound is audible, guys? You are getting my voice? Anyone please confirm. And guys, at this Yourpedia platform, we have launched some micro module for HAL examination and other PSUs also. And yes, all regular classes already started. In today's session, guys, we are going to discuss previous year questions, engineering services previous year questions from thermodynamics related to second law of thermodynamics. So I found close to 84 questions. 84 questions I found related to second law of thermodynamics, and I will try to cover all maximum. At least 60, 65, 70 I will try to cover in the today's session. Yes, thank you, Amir Haider. Yes, good evening. So guys, let's start. Time is very less. We are having exactly 2 hours. So in those 2 hours, I will try to cover those 84 questions which are there, max, which is possible in those 2 hours. So let's start. It's my request to all of you guys. Don't sit idle. You need to participate. You need to answer. You need to try each and every question. If you got the answer, you can mention your answer in the question in the chat box. And if you're not getting the answer, then you need to listen. You need to observe. You need to here I'm going to show the entire question with you in front of you. So, but you need to try. If you will try, then only you will be able to grow, guys. So it's my request to all of you. Please be seated with some kind of pen and paper with you. If you are, if you are engaged with us in by any means, then surely you are going to get the PDF of this class. So the question, you need not to note down any kind of question, but only some rough page you need to have so that you will be able to try each and every question. So guys, let's start. This is question number 1 in front of you. फ्रॉम इंजीनियरिंग सर्विसेज 1992 जो हम क्वेश्चन सोल्व करने वाले बच्चों ये होंगे 1992 से 2015 तक के क्लोज टू 84 क्वेश्चंस रिलेटेड टू सेकंड लॉ ऑफ थर्मोडायनेमिक्स. सेकंड लॉ ऑफ थर्मोडायनेमिक्स. ठीक है, तो ये सारे क्वेश्चन हम आज सोल्व करने वाले हैं. चलिए, सो इन द बिलो फिगर, E is a heat engine, R is a refrigerator, given Q2 plus Q4 that is equal to 3Q1. This is the first data which is given to you, and the COP of the refrigerator is, he is asking you the COP of the refrigerator if the efficiency is 0.4. तो कैसे solve करोगे बच्चों? First thing, like what he is asking you that you need to write. He is asking you the COP, so write COP. What is COP of a refrigerator, guys? COP is the refrigeration effect produced. What is the refrigeration here? How much heat you are extracting? You are extracting Q3 divided by W. So this is the COP of a refrigerator. Yes or no, guys? So whatever he is asking you, that you need to first write Q3 by W. Now, this W you can easily write in comparison with the engine efficiency. Efficiency of a heat engine is nothing but W divided by heat supplied, and this is given to you 0.4. Yes or no? So this W you can write it as 0.4 Q1. This W you can write it as 0.4 Q1. Yes or no, guys? 0.4 Q1. Okay, now one more thing, easily you can observe it here. Guys, here for refrigerator, if you write the first law of thermodynamics, energy balance, you can write it here Q3 plus W, that is equal to Q4. Yes or no? Whatever energy is entering, that is equal to energy leaving. So Q3 plus W, that is equal to Q4, or you can replace it here Q3 equal to Q4 minus W, and Q4 is nothing but 0.4 Q1 minus W. Okay, yes, Q4, not Q4, this is Q4 minus what? Q4 you can write it here from this equation. Q4 equal to 3Q1 minus Q2 minus W. What is W, guys? W is 0.4 Q1. So this data you are having, and this if you will put it here, you will get the answer. So Q3 easily you can replace from this equation 3Q1 minus Q2 minus 0.4 Q1 divided by 0.4 Q1. Remaining all is just the calculation solving, and you will get the answer. So this is 3 by 0.4 minus 1 by 0.4 into Q2 by Q1 minus 1. Okay, And efficiency of heat engine, guys, you know what is efficiency of heat engine? This is nothing but 1 minus rejection, means Q2 by Q1. Okay, so this Q2 by Q1 is nothing but 0.6. Q2 by Q1 is 0.6. Yes or no? So this value, if you will put it here, you will get the answer. So this is 30 by 4 minus 10 by 4 into 6 by 10 minus 1. So this will cancel out. You will get 7.5 minus 1.5 minus 1. So what you will get, guys? You will get 5. So the COP is 5. So how many of you are getting 5 answer, guys? Please tell me. How many of you are getting the 5 COP? COP of the refrigerator is 5. Yes, Amir, very good. Amir ने सबसे पहले आंसर किया, and yes, Amir, your answer is very right. So थोड़ा सा लेंदी था, but you know all questions are not that much lengthy. Okay, so don't worry. You know I'm going in a order. So I picked all question from 1992 to 2015. And you know, guys, sometimes they ask very difficult question, also very easy. So all question we are going to solve. Next question you will find very halwa type. In a second you will be able to answer. You know, so out of those 84 questions, some are very difficult, some are very easy. Okay, some are medium level. Okay, so don't worry. Okay, you can all are previous year. So I have taken all in order only. So this is first question. I hope you all answered. You all are able to understand at least the solution of this particular question, guys. चलिए, तो नेक्स्ट क्वेश्चन पे मूव करते हैं. सो इसके लिए आंसर हो जाएगा डी इज द राइट आंसर फॉर दिस क्वेश्चन. लेट्स मूव टू द सेकंड क्वेश्चन. ड्यूरिंग विच ऑफ द फॉलोइंग प्रोसेस डज हीट रिजेक्शन टेक्स प्लेस इन कार्नोट साइकिल? कार्नोट साइकिल में हीट रिजेक्शन कहां पे होता है बच्चों? ट्राई टू आंसर. दिस इज क्वेश्चन नंबर 2. आपको क्वेश्चन लिखना है, क्वेश्चन नंबर 2 आंसर लिखना है, बिकॉज देन ओनली आई विल बी एबल टू tell you कि you are answering right or wrong. So in Carnot cycle, there is no such constant volume process. There is no such constant pressure process. There is no such constant entropy process. And you know, in Carnot cycle, heat addition and rejection both takes place at constant temperature. Rejection भी और addition भी Carnot cycle में किस पे होता है बच्चों? Constant temperature पे. And if you will draw the diagram, you will get a diagram something like this. For a Carnot cycle, something like this. So these two processes are what? Isothermal. These two processes are isothermal, temperature constant, and these two processes are adiabatic, reversible adiabatic, PV की power gamma equal to constant. And this is a plot for a Carnot cycle, Carnot heat engine. Okay, Carnot heat engine, something like this you can write. So 1 to 2 isentropic compression, then heat addition, okay, then rejection, 3 to 4 expansion, isentropic expansion, then rejection, something like this. So 1, 2, 3, 4, this is your Carnot cycle on PV diagram. Similarly, you can draw it on TS diagram also. When the lower temperature is fixed, आपने lower temperature को क्या कर दिया बच्चों? Fix कर दिया. So COP of a refrigerating machine improved by, then how you can improve the COP of a refrigerator? Abhishek, theory part lecture we are providing. I think there is some kind of content is available, but in live classes we are covering questions only, like all previous year questions. Okay, so recorded session, HPCL recorded lectures, they were also there in the module, and other than those recorded lecture, we are covering live classes also. Okay, chaliye. So when the lower temperature is fixed, you know how you can write COP of a refrigerator, guys? COP of a refrigerator is T lower by T higher minus T lower. Okay, and you know, like for any refrigerator, if you are decreasing the condenser temperature, and if you are increasing the evaporator temperature, means if you are decreasing the temperature difference between condenser and evaporator temperature, you will be able to increase the COP. Okay, so by these two means you can increase the COP. So already he has mentioned the fixed lower temperature is fixed. So if you will decrease the condenser temperature, means T high means condenser temperature. So condenser temperature ko bachcho, if you will decrease, you will be able to increase the COP. So which option is right here? Operating the machine at higher speed? No, this is not making any sense. Operating the machine at lower speed, raising the higher temperature? No. Decreasing means lowering the higher temperature. Option D will be the right answer for this question. बहुत सारे बच्चे C आंसर कर रहे हैं बच्चों, C गलत हो जाएगा. D is the right answer. For any refrigerator or any kind of refrigerating machine, if you are decreasing the condenser temperature, increasing the evaporator temperature, then only you will be able to increase the COP. Chaliye, let's move to next question, question number 4. For a closed system, the difference between heat added to the system and work done by the system is equal to change in. Actually, this is related to first law of thermodynamics. And you know, first law of thermodynamics for any process, you can write it as dQ equal to dE plus dW. And if you're neglecting the kinetic and potential energy changes, neglecting kinetic energy and potential energy changes, you can write first law of thermodynamics for any process as dQ equal to du plus dW. Okay, so the difference of dq minus dw is nothing but internal energy. Option D क्या हो जाएगा बच्चों? This is the right answer for this question. Let's move to next question, question number 5. So there is a solar engine uses a parabolic collector supplying the working fluid at this temperature. A second engine employs a flat plate collector. So this is your first engine. Second engine employs a flat plate collector supplying the working fluid at this temperature. In both the cases, temperature is different. Ambient temperature is fixed for both the cases, 27%. The ratio of maximum work obtainable in both these two cases. तो W1 to W2 ये इसका क्या पूछ रहा है? रेशियो पूछ रहा है. W1 by W2. What is the ratio of the maximum work obtainable in case 1 divided by case 2? अभी देखो, both are getting the solar radiation, but there is a difference in kind of collector. In first case you are having a parabolic collector, in second case you are having a flat plate collector. So collectors are different, so their efficiency, their performance will be different, their work output will also be different. But if I will ask you what is the input to both the collectors, input is same, guys. So these both collector, they are getting solar radiation, so their input is same. So the Q, heat supplied, is same. हीट सप्लाइड क्या है बच्चों? दोनों के लिए क्या है? सेम है. ओके, देन हियर मैक्सिमम वर्क, अगर आपसे मैक्सिमम वर्क पूछ रहा है, इट मींस यू आर अज्यूमिंग कि दिस इज गोइंग टू ऑपरेट ऑन रिवर्सिबल साइकिल. अगर आपसे मैक्सिमम वर्क पूछ ले या मिनिमम रिजेक्शन पूछ ले, इफ एनी क्वेश्चन यू आर गेटिंग कि व्हाट इज द मैक्सिमम वर्क obtained by engine, so you need to think only what कि that engine is operating reversibly, because if the engine is going to operate reversibly, then only you are going to get the maximum work. तो रिवर्सिबल अगर हो जाएगा पहला इंजन, लाइक इफ आई विल राइट हियर फॉर द फर्स्ट केस, so the efficiency for the first is 1 minus T lower by T higher, so it is 300 divided by T higher. T higher will be 773. So this is the efficiency for first. Similarly, what is the efficiency for second, guys? Efficiency for second is 1 minus T lower by T higher. T higher will be this. इसमें अगर आप ऐड करोगे 273, so it will be 353. So it will be 53 by 353, something like this. या इसको ऐसे लिख लो अभी, this only. So this is efficiency of 1, this is efficiency of 2. So what will be the work? W1 will be, you know, efficiency is nothing but W net divided by heat supplied. W by heat supplied. So this is equal to W2 by heat supplied. Heat supplied is same for both the cases. Yes or no? So only you need to equate this W1, W2. So W1, you can write it here, W1 equal to Q into 1 minus 300 by 773. And here you can write this W2 equal to Q into 1 minus 300 by 353. So Q will be cancelled out if you will take the ratio of W1 by W2. So W1 by W2 is nothing but 1 minus 300 by 773 divided by 1 minus 300 by 353. Okay, so इसको करोगे आप, you will get 773 by 473 by 773, and this will be 353 by 53. Yes or no, guys? So this you are going to get. अब इससे कुछ approximate answer आप निकाल सकते हो. Some approximate answer easily you can get out of this. इससे आप कुछ approximate answer easily निकाल सकते हो. So try to get some answer out of this. What is the ratio of the maximum work obtainable in those two cases? So tell me what answer you are getting, guys. Some are saying C. People are mentioning C. Yes, C is the right answer for this question. C क्या हो जाएगा बच्चों? C is the right answer for this question. ठीक है, C will be the right answer for this question. देखो आप यहां से थोड़ा सा आपको अंदाजा लगाना है कि this one to 416. There is a huge difference between these values. Okay, यहां से अगर आप देखते हो, so this is just kind of 8 times of this. इसका कुछ 8 times आपको दिख रहा है. This is kind of 8 times. So roughly it is 8 times, and this is roughly what, 2 times, approximately 2 times. So approximate ratio you can get close to 4. तो ऐसे आपको approximate करना पड़ेगा, otherwise it is sometime it will take some time, much time to solve this. Okay, so exact value you need not to find, just only some approximate value, because there is a huge difference in these values, 1 to 416. So easily you can get if you will observe here. Chaliye, let us move to next question, which is very easy. What is the relationship between COP of a heat pump and refrigerator? This is very simple question. This is question number 5th, and this is now 6th question. So you know guys, COP of heat pump is nothing but 1 plus COP of refrigerator if they are operating between the same temperature ranges, same temperature limit. COP कितना होता है बच्चों? Heat pump का COP is less than infinite, greater than 1. COP of refrigerator is always greater than 0, less than infinite. Okay, so this is the range. This is the range of COP of heat pump and refrigerator. Minimum COP of heat pump is what? COP of heat pump minimum is 1. If you are having, it is not possible, like even reversibly. Okay, so minimum COP of heat pump will be 1. Maximum it will be less than infinite. Similarly, this is the range of COP for a refrigerator. Chaliye, next question guys in front of you. Question number 7th. A reversible heat engine executing 630 cycles per minute. So these are the cycles per minute, draws heat from 2 constant temperature reservoirs. So there are 2 reservoirs. One is at 1200 Kelvin. Another one is at, first one is at 1200 Kelvin. Another one is at 800 Kelvin. So there is a heat engine which is taking heat from these 2 reservoirs. It rejects a heat to a constant temperature reservoir, constant temperature sink at 400 Kelvin. The engine develops 100 kilowatt of the work. So the work developed is 100 kilowatt. Rejects 3200 kilojoule heat per minute. So this is heat rejected per minute, kilojoule per minute. Heat rejected per minute. Now he's asking you this ratio, this heat Q1, Q2. So if you'll assume it here Q1, Q2. So what is this ratio of Q1 by Q2? So he's asking you the ratio of Q1 and Q2. The heat which you are taking from a source at 1200 Kelvin and the heat which you are taking from a source at 800 Kelvin. What is the ratio of that heat? Manas, there is no such dates declared. Soon, within next 1-2 days, I'm going to discuss detailed, strategy for Oil India examination. What you need to prepare, where you need to prepare. Okay, what are the different sources you need to refer for Oil India examination? Exam pattern क्या होता है? Detailed analysis मैं आपके साथ discuss करूँगा in next 2-3 days. ठीक है? You will get the recorded video on Yourpedia channel. ठीक है? Platform, Yourpedia YouTube channel, you will find recorded video. Okay, तो अभी unique thing क्या है? What is a good thing, guys? You know, the module which we have launched for HAL, it is not only for HAL. We are not going to, stop all those videos even after the completion of the HAL examination. So the entire content will be visible to you. You will be able to utilize that entire content up to next 6 months. Okay, and even I think more than that. So that package is going to include different examination. Okay, so there are so many PSUs which for which you can prepare with this single module. Okay, so generally initially we launched it for HAL only, but it is for HAL and other PSUs also. चलिए, so guys, अब उसने क्या बोला आपको? The ratio of heat done, reversible engine. This is a reversible engine. अगर ये reversible engine है बच्चों, so what you can write it here? You can write it here, cyclic integration dq by t, that is equal to 0. Closest inequality, the cyclic integration dq by t will be 0 for any reversible engine. Okay, so here you can write it here, q1 divided by 1200. This will be positive. Why? Because this is a heat addition. Heat addition क्या होता है बच्चों? Heat addition is positive. Plus q2 by 800. This is also positive. Minus q3 by 400. So I'm directly writing here 32 divided by 400, and this is equal to 0. This is equal to 0. Yes or no? तो इसको अगर हम सोल्व करें तो इसको 400 से हटा दो पहले, तो इसको आप 3 लिख सकते हो, दिस यू कैन राइट इट एज 2, दिस यू कैन राइट इट एज 1, सो Q1 by 3 plus Q2 divided by 2, that is equal to 3200. Further if you will solve guys, if you will take LCM 6, तो यहां पे क्या आ जाएगा, you can take it here LCM 6, तो यहां पे क्या आ जाएगा, it will be 2Q1 plus 3Q2, that is equal to 3200. ठीक है, चलिए, so 2Q1 plus 3Q2, that is equal to 00 this. So this is equation number 1. This is our equation number 1. Yes or no? This is equation number 1. Okay, one more equation you can write it here easily. What is that equation guys? From first law of thermodynamics. This is the data which you are, this is the information which you are getting from second law of thermodynamics, but here you can write here first law of thermodynamics also. Using first law of thermodynamics, energy balance, first law of thermodynamics, मतलब अगर हम यहाँ energy balance लगाते हैं, so you can write it here Q1 plus Q2, that is equal to 3200. Output means this is the input, output 3200 plus 100. But what you need to observe it here guys, what you need to observe, this is Q1, this is Q2, fine, whatever will be the unit of this Q3, the same unit you are going to get for Q1 Q2, it's fine, but this 100 is in kilowatt, तो आपको इसको कन्वर्ट किस में करना पड़ेगा, किलो जूल पर मिनट में. इट मींस हियर you need to write 100 plus 100 multiply by 60, because this you need to multiply by what, 60, because in 1 minute you are having 60 seconds, then only you will be able to rightly answer this question. And it is better to convert this into kilojoule per minute. But if you will go for converting this into divide by 60, then the question will become slightly difficult. Why? Because you will get answer in some kind of point, okay, and then you need to solve, and it can take some much time solving in that manner. So it is better to convert this 100 into 60. Here further you can write one more equation, Q1 plus Q2, that is equal to 32 plus 600, so you will get this 6000. This is our second equation. So this equation I'm directly writing here. इस equation को मैं यहाँ लिख देता हूँ, Q1 plus Q2, that is equal to 9200. So this is equation number 2. Yes or no? So now you are having two equations and easily you can solve these two equations. So let me multiply by this by 2. इसको भी मैं 2 से गुना कर देता हूँ और इसको भी मैं 2 से गुना कर देता हूँ. So you will be easily able to write minus minus minus, so this will cancel out, so you will get Q2 equal to 1900 minus कितना आएगा 18400. So this will be this value you are going to get. Okay, so Q2 will be 19200 18400, तो कितना आ जाएगा, this you will get 800. So the Q2 will be 800. This is the first answer we are getting. And if Q2 equal to 800, this value will put it here. इसको अगर मैं यहाँ put कर देता हूँ, Q1 plus Q2, that is equal to 9200. So from that, if you will get Q1 equal to इसको 800 घटाओगे, you will get 8400. So Q1 is 84, Q2 is 800. Then easily you can take this ratio Q1 by Q2, that is equal to 84 divided by 800. You can get some answer. ठीक है, कितना आ जाएगा, आंसर विल बी इन सम काइंड ऑफ 1 पे जाएगा, so it will be go in 1, then 0.5, so answer will be 10.5. okay, 10.5 will be the right answer for this question. Let's see which option is matching. Yes, option D will be the right answer guys for this question. ठीक है, तो 4-5 क्वेश्चन के बाद अगेन वी फाउंड सम काइंड ऑफ व्हाट लेंथी क्वेश्चन. ठीक है, तो कुछ क्वेश्चन बहुत आसान थे, लाइक दिस. These questions are slightly direct question, okay, and this is slightly there is some kind of calculation is there. ठीक है, चलिए, I hope this question is very much clear to guys, all of you. Let's move to next question, question number 8. Question number 8. The value of heat transfer and work transfer for 4 processes of a thermodynamic cycles are given. He is asking you the thermal efficiency and the work ratio. थर्मल एफिशिएंसी पूछ रहा है आपसे, वर्क रेशियो पूछ रहा है, तो आपको आंसर करना है बच्चों ABCD, which one will be the right for this question. थोड़ा मैं और इसको बड़ा कर देता हूं so that clearly you will be able to see this question. You know guys, thermal efficiency is nothing but W net divided by heat supplied. So W net कितना है बच्चों, 500, this is W positive. 550 is W positive, 350 is W negative. So 550 minus 350 कितना आ जाएगा? 200. Okay, 200 आपका क्या आ जाएगा? देखो इससे तो ये कट जाएगा. You will get 200. So 200 is our W net. What is heat supplied, guys? This is heat rejected. Minus is means heat rejected. So heat supplied is 300. So 2 by 3, it means the efficiency is 66.67%. So the efficiency is 66.67%. Yes or no? Now, the second he is asking you the work ratio. So work ratio is nothing but W net by W positive, positive work. So W net कितना है बच्चों? W net is 200. What is positive work? Positive work is 550. Positive work is 550. Okay, तो इसको भी आप सोल्व कर सकते हो. If you will solve it on 5, तो ये आ जाएगा 40, ये आ जाएगा 110. So this you can cancel out. So 4 को अगर आप डिवाइड करोगे, you will get 0.370. So 6 फिर 3. So it will be something like this, 0.363. 0.363, this will be the work ratio. So you can check, guys, which option is matching. 66.7 and 0.63. Option B क्या हो जाएगा? This will be the right answer for this question. Efficiency close to 66% and the work ratio close to 0.3%. Very good, Amir. Amir का अच्छा परफॉर्मेंस चल रहा है बच्चों. Others also, guys, it's my request, please try. ऐसे मत बैठो, ट्राई करो. Each and every question you need to try. Let's move to next question, heat pump. ये क्वेश्चन हो जाएगा हमारा, ये था 8th and this is question number 9. Heat pump working on a reversed Carnot cycle has a COP of 5. तो रिवर्स कार्नोट साइकिल पे हीट पंप वर्क कर रहा है. हीट पंप का सीओपी कितना है? 5. इट वर्क एज ए रेफ्रिजरेंट. इफ इट विल वर्क एज ए रेफ्रिजरेटर, इट्स वर्क इनपुट विल बी 1 किलोवाट. व्हाट इज अ रेफ्रिजरेशन इफेक्ट? तो बड़ा आपको पता है बच्चों, COP of heat pump is equal to 1 plus COP of a refrigerator. So the COP of refrigerator will be 5 minus 1, it will be 4. So 4 equal to refrigeration effect divided by W in. So the refrigeration effect will be W in, which is 1 into 4. So the refrigeration effect produced will be 4 kilowatt. ठीक है, 4 kilowatt will be the refrigeration effect. Yes, Abdullah, good evening. Yes, very good, guys. It's good. After a long time, we all are meeting. Yes. So option D will be the right answer for this question. Let's move to next question, guys. Question number 10. Consider the following statement, the definition of the temperature is due to zeroth law of thermodynamics. Temperature is due to measured actually due to by zeroth law of thermodynamics. Entropy is related to first law of thermodynamics. This is wrong. Entropy is related to second law of thermodynamics. Entropy is related to second law of thermodynamics. Yes, Abdullah, thank you. Internal energy is due to no internal energy is first. From zeroth law we are getting the concept of temperature measurement. From first law we are getting the concept of internal energy. From second law we are getting the concept of entropy. From third law we are getting the concept of reference state, absolute 0 Kelvin. Okay, so reversibility is due to what? Kelvin Planck statement. This is also wrong. ये भी गलत हो जाएगा. Reversibility is not related to Kelvin Planck statement. Heat engine, the concept of heat engine is related to this Kelvin Planck statement. Reversibility, you can relate it with the Clausius statement. This Clausius inequality. With the Clausius inequality, you can relate reversibility, irreversibility. But with the Kelvin statement, there is no such concept of reversibility. Reversibility, irreversibility, that you can relate with second law of thermodynamics. उसको आप second law से तो relate कर सकते हो, but not with the Kelvin, exclusively Kelvin Planck statement. तो I think only option 1 is right. सिर्फ option 1 ठीक होगा, तो option C will be the right answer for this question. C will be the right. Very good, Amir, Ritesh. बिल्कुल सही बच्चों आपके आंसर. Let's move to next question. Question number 11. One reversible heat engine operates between 1600 temperature T2. एक हीट इंजन है जो ऑपरेट कर रहा है 1600 के बीच में और T2 के बीच में. So this is heat engine first. This is HE1. Okay. There is another heat engine which is operating between T2 and 400 Kelvin. So this is HE2. This is HE2. This is HE1. This is HE2. इफ बोथ इंजन हैव सेम हीट इनपुट एंड आउटपुट, दोनों का इनपुट सेम है, आउटपुट सेम है। अरे अगर इनपुट आउटपुट सेम होगा तो दोनों का वर्क क्या हो जाएगा बच्चों? वर्क विल बी सेम। अगर इनपुट सेम है, आउटपुट सेम है, सो इट मींस W1 विल बी इक्वल टू W2। यस और नो? बिकॉज ये क्या होता है, दिस इज हीट इनपुट, हीट एडिशन माइनस रिजेक्शन। एडिशन माइनस रिजेक्शन को ही हम क्या बोलते हैं? वर्क। whatever heat you are adding minus whatever you are rejecting, the difference you are going to get what? The work output. So if addition rejection is same, so work output will be same. And guys, if you are having a series of heat engine, if you are having a multiple engines in series and their work output is same, then the temperature, this temperature T2, this temperature T2 will be average of this. क्या हो जाएगा? T2 will be this 1600 means T1, इसको मैं क्या लिख सकता हूं? If multiple engines you are having in series, so T2 will be, intermediate temperature will be T1 plus T3 by 2, so it will be 1600 plus 400 divided by 2, so the answer will be 1000. आंसर क्या हो जाएगा बच्चों? 1000. अगर इसी क्वेश्चन में बोल देता है एफिशिएंसी सेम क्वेश्चन में अगर मैं आपको बोल दूं एफिशिएंसी सेम है, नॉट वर्क आउटपुट इज नॉट सेम, एफिशिएंसी सेम, तो अगर एफिशिएंसी सेम होता है तो तब आपको क्या लेना पड़ता है? ज्योमेट्रिक मीन। अभी क्या ले रहे हैं हम? अरिथमेटिक मीन। तो अगर वर्क इन आउटपुट सेम होता है तो आपको अरिथमेटिक मीन लेना होता है, और अगर एफिशिएंसी सेम होता है तो यू नीड टू टेक द ज्योमेट्रिक मीन अंडर रूट T1 into T3, देन दैट विल बी द इंटरमीडिएट टेम्परेचर इफ एफिशिएंसी सेम। चलिए नेक्स्ट क्वेश्चन पे मूव करते हैं बच्चों। So this is question number 12 in front of you. Which one of the following sets of changes in the source and sink temperature T1 and T2? So T1 is the source temperature, T1 तो source का है, T2 आपका sink का है, of a reversible engine which results in maximum improvement in efficiency. So ये T1 plus T2, this is T1 plus T2. Let me write it with black only. So this is T1 plus T2, T1 plus delta T, T2 minus delta T, T1 plus delta T. So कैसे आपको लग रहा है how you will be able to improve the efficiency of a heat engine? देखो हीट इंजन एफिशिएंसी, रिवर्सिबल हीट इंजन एफिशिएंसी इज नथिंग बट 1 minus T2 by T1, or what you can say 1 minus T lower by T higher. So the efficiency of heat engine if you want to improve, या तो आप हायर को बढ़ा दो या लोअर को घटा दो. If you want to improve the efficiency of a heat engine, there are two ways. You can go with by increasing higher temperature or lowering lower temperature, but which one is best? It is better to decrease the lower temperature, but lower temperature की limit है. Why? Because higher temperature को बढ़ाओगे तो input भी बढ़ेगा आपका, and there is a limit, there is a kind of what you can say strength limit is there, because when you are increasing the higher temperature there is a metallurgical limit. You cannot go beyond that. Okay, so thermal stresses will induce in the body if you will go for higher temperature. So if I will ask you which one is better out of decreasing the lower temperature or increasing the higher temperature, which one is better? It is better to decrease the lower temperature if you want to improve the efficiency out of these two. But in general, if you want to improve the efficiency, you need to decrease the lower temperature, increase the higher temperature. तो देखो T1 plus delta 2, delta आपको क्या करना है? Which one of the following changes in the source and sink temperature of a reversible engine will results in maximum efficiency? तो इससे बढ़ तो जाएगी, but you cannot say maximum मिलेगा. इससे भी बढ़ जाएगी, but you cannot say maximum मिलेगा. आपने हायर को बढ़ा दिया, लोअर को घटा दिया, so इससे आपको क्या मिलेगी बच्चों? मैक्सिमम एफिशिएंसी मिलेगी. So C is the right answer. जल्दी में A या B आंसर नहीं कर देना है. You need to answer C, because in C you are increasing the higher temperature. हायर को आपने बढ़ा दिया, and lower you are decreasing. So this with this you are going to get the maximum efficiency. Option C क्या हो जाएगा? Right answer हो जाएगा. Yes, minimum बोलोगे पारिक. The minimum T lower which is possible is atmospheric temperature. Atmospheric से कम पे heat rejection is not possible. उसके लिए आपको क्या करना पड़ेगा? वो possible कहाँ पे? Like suppose if you will go in observing some such kind of ocean thermal energy. Ocean में हम क्या करते हैं? We attach a heat engine which takes heat from the solar energy and it rejects heat in the deep sea. Deep sea में हमारे पास temperature क्या होता है? Very lower temperature you will get. So in that case we produce some kind of what work output by taking heat from the solar radiation, rejecting heat into the deep sea. ओके तो वहां पे आप लोअर टेम्परेचर एटमॉस्फेरिक से कम आपको मिल जाता है. बट इन जनरल केस एनी इंजन विच यू आर हैविंग that is going to reject heat at a temperature more than atmospheric only. Even rejecting heat at atmospheric is not possible because some kind of temperature difference is required. So at exact atmospheric temperature you cannot reject heat. Okay, so all real engine, they are going to operate at they are going to reject heat at a temperature more than atmospheric temperature. Okay, if you want to reject heat at a temperature lower than atmospheric, then you need to attach some kind of refrigerator. रेफ्रिजरेटर से आपको पहले लोअर टेम्परेचर मेंटेन करना पड़ेगा, देन ओनली रिजेक्शन इज पॉसिबल एट लोअर टेम्परेचर. Mean temperature of heat addition decreases in case of option C. How you can say mean temperature is decreasing? Mean temperature is what? This is the temperature of heat addition, guys. This is the temperature of heat addition. अभी एक बात समझो, चलो एक बच्चे ने बहुत अच्छा पूछा है, रामपा पंपा, वेरी गुड, आपका नाम बड़ा इंटरेस्टिंग है, रामपा पंपा. तो रामपा आपको क्या समझना है? If you are rejecting, like where you are rejecting heat to the atmospheric gases. Like rejection के लिए condenser we use. So in condenser, what is coming in? The cooling water, the air is coming in. Air को आप reject करते हो heat या water को reject करते हो. So what is the temperature difference between those two? The temperature difference will be less when lower temperature is you are decreasing the lower temperature at atmospheric temperature. So the temperature difference between the exhaust gases and the air, if it is less, then the irreversibility will be less. Same from where you are taking heat. Suppose you are taking heat from some kind of flue gases, from some combustion you are carrying out, and you are getting some kind of flue gases. So engine, the temperature at which you are taking heat, that is almost equal to what? The flue gas temperature. So there will be finite temperature difference, very less, infinitesimally small temperature difference between the flue gases and the source from where, or what you can say system. So if system and the source from where you are taking heat both are at same temperature, then the irreversibility will be less. Don't think they two are different temperature. Obviously they need to have at some different temperature, but the source from where you are taking heat and the sink from where you are rejecting heat, so the system temperature is in almost equilibrium when it is taking heat from the source, and when it is rejecting heat, then also it is in almost in equilibrium. Okay, so I hope you got the point. Chaliye. Next question, guys, question number 13. The operating temperature of a cold storage is -2. Minimum temperature, heat leakage from the surrounding is this. इतना heat leak कर रहा है. Okay, इतना लीक कर रहा है तो मतलब आपको इतना क्या करना पड़ेगा? एक्सट्रैक्ट करना पड़ेगा. So this is indirectly what this is your refrigeration effect. ये क्या आपका refrigeration effect है बच्चों? So ambient temperature is 40 degree Celsius. COP of the refrigeration plant is 1/4 of the ideal. तो पहले तो COP ideal निकाल लो. COP ideal. So COP ideal will be T lower by T higher minus T lower. So T lower कितना है बच्चों? T lower is this 271. Higher minus lower it will be 38. Okay, 38. तो इसको देखो कितना जाएगा. I think this will be close to कितना आएगा? देखो 38 को अगर मैं भेजूंगा I think ये आएगा आपका 8 पे, है ना? चलिए 9 पे ही चला जाएगा. यस 8 पे भेजते हैं इसको. सो 4 6 24 और 6 300, है ना? तो 7 पे ही चला जाएगा. सो दिस यू विल गेट क्लोज टू 7. सो COP इज क्लोज टू 7. ठीक है, COP कितना है आपका? आइडियल COP इज क्लोज टू 7. ठीक है. T lower is what? 271. 2 -2 है ना? -2. So it will be 271. T higher minus T lower, ये कितना हो जाएगा? अच्छा, ये this will be 42 guys. This will be 42. ये कितना होगा आपका? 42 guys. Because the difference between these two is 42. Okay. So now you need to check. अभी इसको चेक करो कितना आएगा. I think then it will be 42. इसको 7 पे भेजते हैं. So this will be close to this. Okay. Close to this. Roughly it will be close to this. ठीक है. 6 पे भेजेंगे तो इट विल बी, तो इसको 6.5 के आसपास लिख लो. अप्रोक्सीमेटली इट विल बी क्लोज टू 6.5. ओके, तो आपका एक्चुअल COP कितना है? COP एक्चुअल इज 1/4 ऑफ दिस. 1/4 मींस, सो इट विल बी 0.25 into 6.5. 0.25 into 6.5. ओके, और इसको आप क्या कर सकते हो? दिस यू कैन इक्वेट इट विद, इसको आप इक्वेट कर सकते हो रेफ्रिजरेशन इफेक्ट प्रोड्यूस्ड डिवाइड बाय W in. Okay, and the refrigeration effect is given to you 30 kilowatt, so easily you will be able to find this W in. Okay, W in को आप easily निकाल सकते हो. Okay, so just tell me what value, what answer you are getting. So W in will be 30 into 4 divided by 6.5. So I think close to 20 you will get. close to 20. Okay, close to 20. So then in that case, because there is no such option with 20, so we can go with option D. हम D के साथ जा सकते हैं. So the option D will be the right answer. Because मैंने बहुत कुछ approximate किया है बच्चों. In this analysis, I approximated lots of things. तो इसको मैंने approximate कर दिया. ठीक है, इसको मैंने approximate करके I am getting answer roughly close to 20. मैंने इसको 20 बोला, but there is no such option and there is a huge difference between these, so easily you can answer option D is the right answer. Otherwise if you want to get exact answer तो आपको थोड़ा सा calculation करना पड़ेगा. ठीक है, चलिए, option D will be the right answer for this question. So please check guys and confirm how many of you are getting option D as the right answer. Let's move to question number 14. Which one is the right representation for a heat pump? इन चारों में से हीट पंप का कौन सा सही रिप्रेजेंटेशन है? देखो ये तो नहीं हो सकता बिकॉज इसमें तो वर्क आउट हो रहा है. दिस इज नॉट पॉसिबल. दिस इज आल्सो नॉट. हीट पंप क्या है? इट इज अ वर्क एब्जॉर्बिंग डिवाइस. एब्जॉर्बिंग डिवाइस, वर्क आपको देना पड़ेगा, तो ये तो नहीं हो सकते. अभी इसमें क्या कर रहे हो आप? यू आर गिविंग वर्क, टेकिंग हीट फ्रॉम द सोर्स, रिजेक्टिंग टू द सिंक. गलत हो जाएगा. हीट पंप में हम क्या करते हैं? वो टेक हीट फ्रॉम द सोर्स. लोअर टेम्परेचर से हम क्या करते हैं? दिस इज टी लोअर. फ्रॉम लोअर टेम्परेचर वी टेक हीट and at higher temperature we reject it. So option C is the right answer, right option for a heat pump. Got the answer guys? Option C will be the right. Very good. Let's move to next question. Similar type of question earlier also we solved. इसमें ज्यादा देर नहीं लगाएंगे. COP of a heat pump equal to 1 plus COP of a refrigerator. Option B is the right answer. ठीक है, चलिए. Let's move to question number 16. Question number 16 guys. Assertion reason question. Heat pump used for heating is a definite advancement over the simple electric heater. Yes. Heat pump क्या है? It is an advancement over heater. Why? Because heat pump में जो heat supplied होती है, heat supplied, this is W in plus W जो आपने extract किया. So in heat pump always heat supplied is more than W in. जितना आप वर्क दे रहे हो उससे ज्यादा आप सप्लाई करते हो हीट पंप में. हीट पंप के अंदर, हीट पंप में द हीट सप्लाइड इज ऑलवेज मोर देन वट एवर वर्क यू आर सप्लाइंग. बट हीटर के अंदर, इलेक्ट्रिक हीटर में बच्चों, हीटर के अंदर मैक्सिमम विद 100% एफिशिएंसी, व्हाट मैक्सिमम इज पॉसिबल? कि हीट सप्लाइड विल बी W in. दिस इज मैक्सिमम पॉसिबल. This is maximum possible in a heater. So we can say कि heat pump is a kind of advancement over heat pump. And if you are using a heat pump, your cost, running cost will be less. Running cost क्या हो जाएगा? heat pump का कम हो जाएगा. Directly also you can answer. Why? How? You know heat pump का minimum COP कितना होता है बच्चों? 1. Minimum COP मिनिमम 1 नहीं होता एक्चुअली में, 1 से ज्यादा होता है. मैंने इक्वली लिखा था, अगर आपके ध्यान है तो मैंने क्या लिखा था? COP ऑफ ए हीट पंप इज ग्रेटर देन 1. तो मिनिमम 1 बोलना एक्चुअली रॉन्ग है. COP इज ऑलवेज ग्रेटर देन 1. अगर 1 है तो दैट इज नॉट ए हीट पंप एक्चुअली. COP will be greater than 1. Greater than 1 means the heat which you are going to supply that will be more than what work you are taking. ठीक है. And इसमें तो efficiency कितना हो सकता है? Maximum 100%. So from that also easily you can answer directly. So assertion is right. Heat pump is far more economical in operation. This is also right. Both are right, and this is the right reason for A. So you can go with option A. Option A क्या हो जाएगा बच्चों? This is the right answer for this question. Okay. Option A. B. Why you are answering B? A is the right answer, guys. Heat pump is far more economical. Running cost of heat pump is very less. But why don't we use heat pump? Because the initial cost of heat pump is more. That's why, because in countries where the winter season is very less, you know, in India, the winter season is very less as compared to the summer season. Okay. And second thing, in a very geographically, like if you will observe the areas in very less number of regions, you like in north, mostly in north region only, the winter season you will get very low temperature. Okay. In winter season, like suppose if you observe lower temperature in South India, the temperature becomes almost normal. So there is no such kind of heating system required in South, even in winter. Okay, that's why we don't use heat pump. Okay, but heat pump is far more economical than your heater. चलिए, इसमें आप एक चीज सोच सकते हो कि एडवांसमेंट है हीटर में, इकोनॉमिकल है, हालांकि आप इसमें ठीक है, मेरे ख्याल से ये आप कर सकते हो, है ना. अगर आप ये भी सोच सकते हो, सम स्टूडेंट दे कैन थिंक कि सर एक्चुअली यहाँ पे आना क्या चाहिए था कि सर heat rejection is more, that's why this is more economical. But economical hai, that's why this is advancement na, so they are related. Economical hai, advancement hai, that's why it is economical. So both are related. Chaliye, let's move to question number 17. Heat transfer takes place according to what? Heat transfer takes place according to what? Yes, yes, Ritesh. Heat supplied is more than heat input. Heat transfer takes place according to second law of thermodynamics. Heat transfer किससे होता है बच्चों? Second law of thermodynamics. According to second law of thermodynamics, heat transfer takes place from higher temperature to lower temperature. Next question, guys, in front of you. Question number 18. A refrigerating machine working on reverse Carnot cycle takes 2 kilowatt heat from the system while operating between temperature limit 300 and 200 Kelvin. COP and power consumed. आपसे रिवर्स्ड कार्नोट साइकिल पे है, मींस दिस इज द रिवर्सिबल डिवाइस. सीओपी पूछ रहा है आपसे एंड ही इज आस्किंग यू अबाउट द पावर. तो रेफ्रिजरेटिंग मशीन है, सो सीओपी विल बी टी लोअर बाय टी हायर माइनस टी लोअर, सो इट विल बी 200 by 300 minus 200, so it will be 2. COP will be 2. This is first option. And if COP is 2, what is this? This is refrigeration effect divided by W in. So the refrigeration effect is what? It is taking 2 kilowatt heat from the system. So this is 2, this is W in. So W in is what? This is 1 kilowatt. So COP2, W in is 1. So answer will be C is the right answer. Option C क्या हो जाएगा बच्चों? This will be the right answer for this question. Option C will be the right answer. Let's move to next question, guys. Question number 19. Again, assertion reason question. Second law of thermodynamics is called the law of degradation of energy. Is it right, guys? बिल्कुल सही है. Second law of thermodynamics is the law of degradation of energy. You know, in any real process, energy degrades. The quality of energy degrades. The total energy is conserved. Energy तो conserved रहता है, but due to irreversibility in the system, okay, due to some kind of dissipative effects, friction, the quality of the energy, the work potential we lose. So in real case, in real system, there is a loss in available energy, and loss of available energy is nothing but what that we can mention as a what? Degradation of energy. So quality we are losing in all real processes, we lose the quality of energy. You can take any example, like suppose there is a light source, light bulb we are using, we are supplying electricity, and what you are getting, whatever energy you are getting, that is at a what? At a level lower than the energy which you are supplying. So in all any real process there is a degradation of energy. So this is right, and this idea we are getting through second law of thermodynamics only. Energy does not degrade each time as it flows through a finite temperature difference. This is wrong. Reason गलत है. Energy does not degrade. Degrade तो करता है. This is not right. Assertion is right. So I think you can go with C. Assertion right है, reason गलत है. So C क्या हो जाएगा? This will be the right answer for this question. Next question, question number 20. A heat pump flow operating on Carnot cycle. Carnot मतलब reversible हो गया. From a reservoir at 300 and 600, the coefficient of performance. बहुत आसान क्वेश्चन है. Heat pump. So heat pump क्या होता है बच्चों? This is T higher by T higher minus T lower. So 600 divided by 600 minus 300. So the COP will be 2. Option C क्या हो जाएगा? Right हो जाएगा. Option C will be the right answer for this question. Let's move to next question, guys. So again, there is an assertion reason question. Heat cannot spontaneously pass from a colder system to a hotter system without simultaneously producing other effect in the surrounding. बिल्कुल सही है. Heat always naturally heat flow from higher to lower. Lower to higher is not possible. So this is right. Assertion तो ठीक कह रहा है. External work must be put into the heat pump so that net heat can be transferred from colder to hot body. So this is also right. Some kind of work you need to supply. If you want to transfer heat from lower temperature to higher temperature, so you need to supply some kind of work. Okay. External work must be put into the heat pump so that heat can be transferred from a cold to a hot body. Heat cannot be spontaneously passed. So these both are right, both are related. So you can go with option A. आप option A के साथ क्या कर सकते हो बच्चों? You can go with option A as the right answer. चलिए. Question number 22. So a thermodynamic system may be considered as a quantity of working substance which with which interaction of heat and work are studied. A thermodynamic system may be considered as a quantity of working substance with which interaction of heat and work are studied. बिल्कुल सही है. Energy in the form of work and heat are mutually convertible. Energy in the form of work and heat are mutually convertible. This is wrong. Conversion of heat into work is not possible completely. Conversion of heat into work is not possible completely. Is not possible completely. ठीक है. So reason is not right. Reason सही नहीं है. तो आपका आंसर कौन सा सही हो जाएगा बच्चों? ऑप्शन सी विल बी द राइट आंसर फॉर दिस क्वेश्चन. ठीक है. सी क्या हो जाएगा? दिस विल बी द राइट. आई होप यू गॉट द पॉइंट गाइस. प्लीज कंफर्म. इज दैट फाइन? ऑप्शन सी विल बी द राइट आंसर. रीजन असर्शन ठीक है, रीजन गलत है. सी विल बी द राइट आंसर. नेक्स्ट क्वेश्चन, लेट मी पुट इट हियर. क्वेश्चन नंबर 23. A heat engine receives 1000 kilowatt of heat to a constant temperature 285 degrees Celsius. Reject heat this much to a heat at 5 degrees Celsius. Consider the following thermodynamic cycle. तो बताओ ये जो इंजन है ये कैसा इंजन है? कार्नोट है, रिवर्सिबल है, इरिवर्सिबल है? सो हाउ टू चेक गाइस? आपको क्या चेक करना पड़ेगा? पहले तो आपको रिवर्सिबल एफिशिएंसी चेक करनी पड़ेगी. एफिशिएंसी रिवर्सिबल. सो रिवर्सिबल एफिशिएंसी ऑफ अ हीट इंजन इज नथिंग बट 1 minus T lower by T higher. So 1 minus, what is T lower guys? T lower is 5, means 278, and the T higher is what? This will be 285 plus 273. 273. तो ये आपकी आ जाएगी रिवर्सिबल एफिशिएंसी. दैट यू नीड टू सॉल्व. मैं बताऊंगा कैसे करना है. एंड व्हाट इज एक्चुअल एफिशिएंसी? एक्चुअल एफिशिएंसी ऑफ हीट इंजन. एक्चुअल एफिशिएंसी कितना हो जाएगा? इट विल बी W net, W by heat supplied. Engine receives 1000. कितना रिसीव कर रहे हो? 1000. कितना रिजेक्ट कर रहे हो? 492. तो वर्क कितना है बच्चों? वर्क क्या होता है? वर्क इज इक्वल टू सप्लाइड माइनस रिजेक्शन. हीट सप्लाइड माइनस रिजेक्शन इज वर्क. सो सप्लाइंग कर रहे हो 1000, रिजेक्ट कर रहे हो 592, मींस वर्क व्हिच यू आर गेटिंग इज 508. 508 means the actual efficiency is 0.508. और सॉरी फ्रैक्शन में लिख रहा हूं मैं. सो द एक्चुअल एफिशिएंसी इज 50.8%. दिस इज एक्चुअल एफिशिएंसी. दिस इज एक्चुअल एफिशिएंसी. एंड दिस आल्सो यू कैन सोल्व. इसको भी सोल्व कर लो. सो दिस विल बी 1 minus 278 डिवाइड बाय कितना आ जाएगा? 8 15 एंड इट विल बी 5. ओके. सो फर्दर यू कैन सोल्व. इसको आप दोबारा सोल्व कर लो. सो इट विल बी 558 डिवाइड बाय 278 डिवाइड बाय 558. तो देखो कितना आएगा. सो इट विल बी 0 एंड 5 है तो इट विल बी 8 एंड इट विल बी 2. सो 280 बाय 558. 280 बाय 558. अब इसको तो आपको डिवाइड करना ही पड़ेगा. देयर इज नो सच ऑप्शन विद यू बिकॉज देन ओनली यू विल बी एबल टू कंपेयर. सो दिस इज एफिशिएंसी रिवर्सिबल. एफिशिएंसी रिवर्सिबल चेक कर लो भाई. 280 डिवाइड बाय 558. तो ये करना ही पड़ेगा. देयर इज नो सच ऑप्शन. ठीक है. बताओ मेरे को विच वन विल बी द केस. गाइस मैं आपको बता देता हूं. अगर आपका रिवर्सिबल एफिशिएंसी इज इक्वल टू एक्चुअल एफिशिएंसी आ रहा है, मींस द गिवन इंजन इज ए कार्नोट इंजन और रिवर्सिबल इंजन. गिवन इंजन क्या है आपका? कार्नोट है या रिवर्सिबल इंजन है. एंड इफ एक्चुअल रिवर्सिबल एफिशिएंसी इज कमिंग आउट मोर देन एक्चुअल एफिशिएंसी, इट मींस द गिवन इंजन इज इरिवर्सिबल. ये रिवर्सिबल है. रिवर्सिबल कब होगा? अगर दोनों इक्वल आ जाती हैं. इरिवर्सिबल कब होगा? इफ एक्चुअल इज कमिंग आउट मोर देन रिवर्सिबल इज कमिंग आउट मोर देन एक्चुअल. बट इफ रिवर्सिबल इज कमिंग आउट लेस देन एक्चुअल, देन दैट इंजन इज इम्पॉसिबल. तो वो क्या हो जाएगा? इम्पॉसिबल. इंजन क्या हो जाएगा बच्चों? इम्पॉसिबल. सो एक एफिशिएंसी अपने पास ऑलरेडी है, दूसरे को भी चेक कर लो एंड इजीली यू कैन गेट योर आंसर कि दिस पर्टिकुलर इंजन इज व्हाट? द कार्नोट इंजन, रिवर्सिबल इंजन और इम्पॉसिबल इंजन. ठीक है. तो प्लीज ट्राई टू आंसर एंड टेल मी व्हाट यू आर गेटिंग. थोड़ा ऑप्शन भी देख लेते हैं. देखो 1 एलोन तो हो नहीं सकता. ये तो हो नहीं सकता क्योंकि होंगे तो दोनों होंगे ना, 1 and 2. अकेला 1 तो नहीं हो सकता. ठीक है. अकेला 3 भी नहीं हो सकता. दिस इज आल्सो रॉन्ग. अकेला 3 भी नहीं हो सकता. सॉरी, अकेला 3 तो हो सकता है. अकेला 3 तो हो सकता है. तो 1 अकेला नहीं हो सकता. 3 हो सकता है. ठीक है. एंड 1 and 2. ये भी हो सकता है, ये भी हो सकता है, ठीक है, ये भी हो सकता है और ये भी हो सकता है, 1 एंड 2। तो इन तीनों में से बताओ, पहला तो नहीं हो सकता, बी भी हो सकता है, सी भी हो सकता है, डी भी हो सकता है। तो व्हाट यू फील, विच वन विल बी द राइट, विच वन विल बी द राइट? तो मैं इसके लिए थोड़ा सा आप चेक करना व्हाट यू विल गेट। दिस इज आई थिंक क्वेश्चन नंबर कौन सा है हमारे पास, क्वेश्चन नंबर 23। सो इसमें जो एफिशिएंसी आएगी, दिस विल बी कम आउट 50 पॉइंट, ये आ जाएगा आपका 0.5017। अगर आप यहां पे इसको सोल्व करोगे, सो दिस रिवर्सिबल एफिशिएंसी विल कम आउट 0.507, 0.507, okay, and which is what, which is lower than the actual efficiency. This is 0.508, 50.8, वो 50.8 है, and this is coming out 0.517, 0.5017, yes, 5017, 5017. So the reversible efficiency is less than the actual efficiency. It means the given engine is impossible. Given engine क्या है? Impossible. And there is no such option with impossible. Impossible तो कोई है ही नहीं है. It means option D will be the right. None of the above will be the right answer. Option D क्या हो जाएगा बच्चों? This is the right answer. Impossible. The given engine is impossible. Got the idea, guys? D will be the right answer for this question. Very good. कितने बच्चे डी कर रहे हैं? एक बच्चे ने आंसर किया डी, श्रीपल्ली। श्रीपल्ली, आपका आंसर ठीक है बच्चों, बाकी भी चेक करो। रितेश, अमीर, डी विल बी द राइट आंसर गाइस, प्लीज चेक योर आंसर। चलिए, लेट अस मूव टू नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 24। 24। अच्छा, एक क्लैसियस-क्लैपेरोन इक्वेशन कहां से आ गया सेकंड में? चलिए इसको सोल्व कर देते हैं। क्लैसियस-क्लैपेरोन इक्वेशन is given by, you know guys, this you can remember easily by thermodynamic relationship SPVT. So easily you can write del S या dP by dt at T saturation, keeping the volume constant. Okay, so this is equal to del S by del V at temperature constant. Okay, so this you can write it as what? dP by dt saturation, that is equal to HFG by T saturation into VFG. So this is your Clausius-Clapeyron equation. This is your Clausius-Clapeyron equation. dP by dt saturation, that is equal to HFG by T saturation into VFG. Option B is the right answer. B will be the right answer for this question. Let's move to next question, guys. Question number 25. Again, third time this type of question is coming. COP of a heat pump is this, refrigerator is this. So heat pump क्या होता है भाई? Heat pump minus refrigerator. Heat pump minus refrigerator, that is equal to 1. Option B will be the right answer. Option B क्या हो जाएगा? This will be the right answer for this question. Let's move to next question, guys. 26. Consider the following statement. The first law of thermodynamics is a law of conservation of energy. बिल्कुल सही है. Perpetual motion machine of first kind converts energy into equivalent amount of work. No, this is not PMM1. This is PMM2. ये तो PMM2 की बात कर रहा है. PMM2 का efficiency होता है 100%. PMM2 converts entire input into output. PMM1 is a machine which producing work without getting any input. तो PMM1 तो इनपुट ही नहीं लेता है और आउटपुट देता है, तो ऐसा तो कोई मशीन पॉसिबल नहीं है. ओके, सो PMM1 is the machine which is producing work without getting any kind of input. PMM2 is a machine which is converting entire input into output, 100% efficiency. Okay, a closed system does not exchange work or energy. This is wrong. Closed system में work और energy का तो exchange हो सकता है. There will be no exchange of the mass. Second law of thermodynamics stipulates the law of conservation of energy and entropy. This is also wrong. So only one is right. Only one right है बच्चों. Closed system does not exchange work or energy with the surrounding. तो क्या आंसर हो जाएगा? हम एक स्टेटमेंट अलग बना देते हैं, E none. ठीक है, none E will be the right answer. ठीक है, तो E मैंने बना दिया एक ऑप्शन. So only one is right. Only statement 1 is right. ठीक है बच्चों, option E none will be the right answer for this question. ठीक है, is that clear guys? तो मैं थोड़ा सा एडिट कर रहा हूं उसमें. Option E will be the right answer. Let's move to next question. 26, 27. स्टेटमेंट 1, नेगेटिव टेम्परेचर्स आर इंपॉसिबल ऑन केल्विन स्केल। बिल्कुल सही, केल्विन स्केल में देयर इज नो सच नेगेटिव स्केल। केल्विन स्केल में कोई भी नेगेटिव टेम्परेचर नहीं होता। केल्विन स्केल इज थर्मोडायनामिक टेम्परेचर स्केल, बिल्कुल सही है। सो बोथ आर राइट। तो ऑप्शन 1 ही क्या हो जाएगा आपका, सही हो जाएगा। ऑप्शन ए विल बी द राइट आंसर, बोथ स्टेटमेंट्स आर राइट। You know, this Q1 by Q2, this is equal to T1 by T2. This is known as thermodynamics temperature scale. इसी को क्या बोलते हैं, thermodynamic temperature scale. Why? Because with this, like if you will take temperature T at any temperature T, or here you can write TP, triple point temperature. This is equal to Q, any Q at triple point TP. So temperature you can measure by measuring the heat. By measuring the heat, you can measure the temperature. TTP by QTP. Okay, so this is a kind of constant. This is kind of constant. So here temperature is a function of heat. Although heat is not a property, but in thermodynamic temperature scale, heat is a thermodynamic property. तो ऐसा क्वेश्चन पूछ सकता है आपसे कि थर्मोडायनामिक टेम्परेचर स्केल में, इन थर्मोडायनामिक टेम्परेचर स्केल, in thermodynamic temperature scale, heat is the thermodynamic property. Heat is the thermodynamic property. तो ये आपको थोड़ा सा पता होना चाहिए. He can ask you THER, thermodynamics, thermodynamic property. Go to the point, guys. The property which you are using, the property in which you are measuring the change, to measure the change in temperature, that is known as thermometric property. तो थर्मोडायनामिक टेम्परेचर स्केल में हीट आपका क्या होता है, थर्मोमेट्रिक प्रॉपर्टी. तो बोथ आर राइट. लेट्स मूव टू नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 28. The working temperature in evaporator and condenser coils are this. तो लोअर टेम्परेचर क्या है बच्चों, T lower is 250 Kelvin, T higher is 300 Kelvin. COP of refrigerator is 0.8 of the maximum COP. So COP maximum या reversible कितना हो जाएगा, refrigerator है, yes it is a refrigerator, so it will be T lower by T higher, so this divided by this, so the maximum COP is 5. So actual COP actual will be 0.8 of this, so the actual COP is 4. Actual COP is 4, and COP is nothing but refrigeration effect divided by W in. पावर कितना है, 1 किलोवाट आपसे रेफ्रिजरेशन इफेक्ट पूछ रहा है. सो द रेफ्रिजरेशन इफेक्ट विल बी 1 into 4, so it will be 4 kilowatt. 4 kilowatt is the refrigeration effect which you are going to get in this case. So option A क्या हो जाएगा, this is the right answer for this question. Option A is right. Very good Amir. Option A is the right answer for this question, guys. ठीक है. Let's move to next question, question number 29. Assertion reason question, efficiency of a reversible heat engine operating between temperature limit T1 and T2 is maximum. बिल्कुल सही है. T1 and T2, any reversible heat engine efficiency is depends on the temperature limits only. Efficiency of a reversible heat engine is greater than of an any irreversible engine. तो बिल्कुल सही है, ये भी सही है, ये भी सही है. तो ऑप्शन ए क्या हो जाएगा आपका, सही हो जाएगा. रिवर्सिबल इंजन व्हिच इज ऑपरेटिंग बिटवीन एनी टू टेंपरेचर लिमिट्स विल हैव मैक्सिमम एफिशिएंसी. द एफिशिएंसी ऑफ रिवर्सिबल इंजन विल ऑलवेज बी मैक्सिमम, विल ऑलवेज बी मोर देन द एफिशिएंसी ऑफ एनी irreversible heat engine operating between the same temperature limit. Next question 30. COP of a heat pump is more than COP of a refrigerator version. सही है. Pumping of heat requires less work related to extraction of heat. तो मैं आपको टाइम दे रहा हूं, ट्राई टू आंसर. अरे ये तो ठीक है बच्चों, दोनों सही हैं 29th में. तो 30th क्वेश्चन में व्हाट यू विल आंसर इन दिस क्वेश्चन गाइस. 30th क्वेश्चन इन फ्रंट ऑफ यू. COP of a heat pump is more than COP of a refrigerator. So what do you think guys, which one is right? This is right, बिल्कुल सही है. COP of a heat pump is more. Pumping of a heat requires less work related to extraction of evaporator. This is wrong. Pumping, it depends. Like for any reversible engine का जो pumping है वो किस पे डिपेंड करेगा. How much work you need to supply, that depends on the temperature limit. वो टेम्परेचर लिमिट पे डिपेंड करेगा. इट इज नॉट गोइंग टू डिपेंड ऑन लाइक वेदर यू आर एक्सट्रैक्टिंग हीट और रिजेक्टिंग हीट. ओके, सो दिस इज रॉन्ग. ये रीजन क्या है आपका, गलत है. सो देन ऑप्शन सी क्या हो जाएगा, दिस विल बी द राइट आंसर. ऑप्शन सी विल बी द राइट आंसर फॉर दिस क्वेश्चन. assertion सही है, रीजन इज रॉन्ग. For this question, Dipanshu Das, A is not right. A is right for this. इसके लिए A सही है. For this 30th question, C is right. Next question in front of you. Question number 31. A reversible heat engine operates between T1 and T2. Energy rejected by the engine is received by the second reversible heat engine. Means he is talking about the engines in series. There are multiple engines in series. Multiple engines in series and their efficiency is same. Efficiency same तो मैंने बताया था. मीन टेम्परेचर क्या होगा, इंटरमीडिएट टेम्परेचर विल बी ज्योमेट्रिक मीन. एफिशिएंसी अगर सेम है, एफिशिएंसी ऑफ 1 इक्वल टू एफिशिएंसी ऑफ 2, द इंटरमीडिएट टेम्परेचर विल बी ज्योमेट्रिक मीन T1 into T2. वर्क आउटपुट अगर सेम होता है तो क्या होता है, अरिथमेटिक मीन. ठीक है, चलिए 32. A reversible heat engine receives 6 kilojoule of heat from a thermal reservoir at temperature 800 Kelvin and 8 kilojoule of heat from a source 600 Kelvin. तो बना देते हैं दो सोर्स 800 Kelvin and this is another source at 600 Kelvin. There is a heat engine which is taking some heat. इससे कितना ले रहा है, 6 kilojoule. From this you are taking 8 kilojoule of heat and you are rejecting heat to what, a sink at 600 Kelvin. 6 or what, 100 Kelvin. किसको रिजेक्ट कर रहे हो आप, a sink at 100 Kelvin. How much you are rejecting you don't know. थर्मल एफिशिएंसी पूछ रहा है आपसे, क्या पूछ रहा है, थर्मल एफिशिएंसी. सो गाइस दिस इज अ रिवर्सिबल इंजन. कैसा इंजन है बच्चों, रिवर्सिबल इंजन. द गिवन इंजन इज अ रिवर्सिबल इंजन एंड इफ दिस इंजन इज अ रिवर्सिबल इंजन देन डेफिनेटली यू कैन राइट साइक्लिक इंटीग्रेशन dq by t equal to 0. For any reversible heat engine, cyclic integration dq by t equal to 0. And for irreversible engine, cyclic integration dq by t will be less than 0. And if dq by t, cyclic integration dq by t is greater than 0, that kind of engine is impossible. That is actually a violation of second law of thermodynamics. Okay? So cyclic integration dq by t will always be less than equal to 0. क्या होता है बच्चों, साइक्लिक इंटीग्रेशन dq by t लेस देन इक्वल टू 0. ग्रेटर देन 0 क्या हो जाता है, वायलेशन हो जाता है. चलिए तो इसको लिख दो यहां पे एंड देन इजीली यू विल बी एबल टू सोल्व. मैं यहां कर देता हूं इसको सोल्व. सो 6 divided by 800, this will be positive. 8 divided by 600 minus q3 divided by 100, that is equal to 0. तो इसको हटा दो, 100 को हटा दो, तो यू विल गेट 48 36 प्लस 64, that is equal to q3. So the q3 equal to 48 divided by 100. यही आएगा. Yes. So this I am taking as LCM. इसको मैंने LCM ले लिया. This I am taking as LCM. This will go this side. Okay. So this is about q3. अच्छा ये रिवर्स हो जाएगा बच्चों. This will be reverse. Okay. This will be just reverse of this. तो मैं again इसको मैं लिख देता हूं. Let me write it here again. थोड़ा सा हमने जल्दी कर दिया इसको, तो मैं again let me observe here. So this is heat which you are taking from a source at 600. So here you can write 6 by 8 plus 8 by 6. This is equal to q3. ठीक है. So here you can write q3 equal to 48. तो इसको इससे करोगे 6 36 plus this will be 800 है ना. So it will be 100 by 48. Okay, it will be 100 by 48, not 48 by 100. ठीक है, 100 by 48. So this is q3 and he is asking you about the efficiency. So q3 we are having. So efficiency क्या होता है बच्चों, efficiency of any heat engine is 1 minus rejection by supplied. So 1 minus q3 supplied is q1 plus q2. So the efficiency will be 1 minus 100 by 48 divided by 14. Because this is 6, this is 8. Okay, then easily you will be able to find out the efficiency. The efficiency will be 1 minus 100 by 48 into 14. तो इसको थोड़ा सा सोल्व कर लेते हैं. Let's see. And you can approximate also. इसको approximate भी कर सकते हो. Otherwise you can solve if you are interested. Exact value तो ये आ जाएगा आपका 2 पे जाएगा तो 50 आ जाएगा. ये आ जाएगा 7. This will be 25 and this will be 24. Okay. तो इसको सोल्व करते हैं, तो दिस विल बी 24 into 7 minus 25 divided by 24 into 7. ठीक है, देखो क्या आ रहा है आपका. सो दिस विल बी 28 2 and it will be 16 minus 25 divided by 168. So just tell me what efficiency guys you are getting. So efficiency will be, इसको इसमें से कट करोगे तो 18 18 और 25, it will be 143 divided by 168. So can you tell me guys what answer you are getting? 148 divided by 168. So easily you can try. आप इसको ट्राई कर सकते हो. यहां से कितने पे जाएगा? 8 पे ही जाएगा. 8 पे जाएगा ना. बाकी का आप ट्राई करो and tell me what answer you are getting. Tell me what answer you are getting. Because ये तो नहीं होंगे, these answers तो नहीं होंगे, but अभी 0.8 से तो ज्यादा आएगा. 0.8 से ज्यादा आएगा तो then you can answer easily. 0.8 से ज्यादा आएगा तो answer will be 85. तो हम आंसर कर सकते हैं approximate. Okay, because this will be more than 8.8, so the answer will be 85. Okay, exact answer you can check. ठीक है, exact आप चेक कर सकते हो what answer you are getting. ठीक है बच्चों, so I hope this question is very much clear. थोड़ा सा calculation part था, but it is easy if you will go with simple approach. Like आपको कुछ भी सोल्व नहीं करना है बच्चों, यहाँ पे कुछ भी काटना नहीं है, मतलब मिनिमम करना है कैलकुलेशन वर्क, सो दैट यू विल बी एबल टू सिंप्लीफाई. ओके, कैलकुलेशन का किसी भी एग्जाम में देयर इज अ वेरी सिंपल वे. आपको उसको फर्स्ट स्टेप पे आपको कैलकुलेट नहीं करना है. फर्स्ट यू नीड टू रिड्यूस to the up to the level which is possible. After reducing, at last only you need to calculate. लास्ट में डिवाइड मल्टीप्लाई कुछ भी करना लास्ट में करना है, बट बिफोर दैट यू नीड टू प्रोसीड विद व्हाटएवर वे यू आर रिड्यूसिंग. ठीक है, यहां पे अगर डिवाइड करके निकालने लग जाओगे देन इट विल टेक मच टाइम. ठीक है, यहां पे इसको डिवाइड करना इज इजी, यू विल गेट डी. चलिए, आई थिंक दिस इज नाउ वी आर हैविंग क्वेश्चन नंबर 33. A heat pump for domestic heating operates between a cold system at 0 degree Celsius, hot system at 60 degree Celsius. What is the minimum electric power consumption? अरे भाई मिनिमम बोल दिया ना, तो इट मींस मिनिमम कब होगा? जब ये रिवर्सिबल होगा. जब ये क्या होगा? रिवर्सिबल. तो रिवर्सिबल हीट पंप का COP हीट पंप रिवर्सिबल क्या होता है बच्चों? दिस इज T हायर बाय T हायर माइनस T लोअर. तो निकाल लो T हायर कितना है? 60 को इसमें 273 करोगे तो इट विल बी 323 divided by 60. 323 divided by 60. Yes or no? 323 divided by 60. So this is equal to what? Heat supplied by W in. Heat supplied by W in. Power consumption पूछ रहा है. Rejection कितना है बच्चों आपका? Rejection is this. This is rejection. अभी ये rejection है बच्चों. This is rejection. Rejection क्या होता है? Rejection is W in plus heat supplied. Okay, so W in is nothing but rejection minus heat supplied. So इसको आप यहाँ पुट कर सकते हो, heat supplied by heat supplied minus heat rejection. W in equal to heat supplied minus rejection. Rejection minus supplied. So this is rejection minus supplied. तो इसको भी यहाँ लिख देते हैं. So this is rejection minus supplied. Okay, so from that 323 divided by 60 equal to 1 by rejection by supplied minus 1. Further if you solve guys, you will get rejection by supplied minus 1, that is equal to, इसको reverse कर दो, 60 by 323. Okay, so Q rejection by supplied equal to 1 plus 60 by 323, so it will be 393 by 323. So the supplied heat supplied पूछ रहा है आपसे, क्या पूछ रहा है बच्चों? Is asking you what? W in. He is asking you W in. Okay, what is asking you? Let me see. Power consumption, minimum power consumption. Okay, he is asking you the minimum power consumption. ठीक है, मिनिमम पावर कंजप्शन. तो देन इन दैट केस गाइस इट इज बेटर टू रिप्लेस दिस. इसको रिप्लेस करते हैं हम रिप्लेस किसको करते हैं बच्चों? इसको रिप्लेस कर देते हैं यहाँ पे, बिकॉज ही इज आस्किंग यू द W. लेट्स रिड्यूस, ट्राई टू रिड्यूस सम स्टेप्स कुछ स्टेप्स को रिड्यूस करने की कोशिश करते हैं. सो ही इज आस्किंग यू द W. सो लेट मी रिप्लेस दिस हीट सप्लाइड ओनली इन टर्म्स ऑफ व्हाट. इसको हम रिप्लेस कर सकते हैं किसके साथ? सप्लाइड इज व्हाट, हीट सप्लाइड कितना होगा? इट विल बी रिजेक्शन माइनस W इन. तो चलो यहां से आप इसको निकाल लो, पहले सप्लाइड निकालो बच्चों. इट इज बेटर टू फाइंड आउट हीट सप्लाइड यहां पे, या कुछ रेशियो आप यहां से निकाल सकते हो. सो दिस यू कैन राइट इट एज रिजेक्शन माइनस W in divided by W in. Okay, so rejection by W in minus 1. Okay, so this is 323 by 60. So this we know, ये तो अपने को पता है बच्चों. This we know, rejection is given to you. Rejection is given to you, then easily you will be able to find out the work. Rejection is 8,000 kilojoule per hour, 80,000 kilojoule per hour. So rejection is 80,000 divided by 60. ओके, तो यहां पे इसको पुट कर दो. 1 प्लस 323 बाई 60 दैट इज इक्वल टू 80,000 डिवाइड बाई 60 इंटू W इन. ठीक है. सो फर्दर यू कैन रिड्यूस, यू कैन राइट इट हियर 393 डिवाइड बाई 60 दैट इज इक्वल टू 80,000 डिवाइड बाई W इन. ओके, इंटू 60. सो दिस 60 will be cancelled out. So you will get W in roughly close to what? इसको मैं 400 मान सकता हूं बच्चों. Can I assume it as 400? क्या मैं इसको 400 मान सकता हूं? Yes, it is close to that. So it will be close to 200. 200. Okay. 200. अभी देखो आंसर किस में आ रहा है. This is 80,000 kilojoule. Heat rejected. He is asking you the power. अभी ये किस में आएगा हमारा? This answer, because we have converted this. हमने इसको convert कर दिया है. This is 80,000 kilojoule per hour. 80,000 kilojoule per hour. तो hour को हमने क्या किया? We have divided this into what? By 60. So we got this answer in kilowatt. Okay. तो ये हमारा kilowatt में आ गया. So this is 1 plus 323 by 60. So it will be 393 by 60. And this will be 80,000 by 60 into this. So 60 will be cancelled out. You will get this. So try to check guys what you are getting. I think I'm right here. Yes. So 323 by 60, this is the COP, reversible maximum. Minimum temperature is 0, so 273 by 323 by 60. So please check it guys. I think I'm right. There is some kind of calculation mistake. Let me check. So 323 by 60, this is supplied, heat supplied by W in. Supplied we can write it as rejection minus W in. Okay. So the rejection is given to us. So rejection by W in minus 1. Rejection is given to us this. So 1 plus 323 by 60. So it will be 393 by 60, which is 80,000 by W in into 60. 60 will be cancelled out. W in will be this. तो मेरे ख्याल से सही है बच्चों. You also can check 80,000 in kilojoule per second. मतलब in kilowatt divided by 393. Okay. तो मेरा तो ये आ रहा है. Let me see what answer they have given for this question. This is question number 33. Yes guys, so please check. अच्छा ये आवर था तो हमने एक 60 से तो डिवाइड कर दिया. देयर विल बी वन मोर 60 गाइस. एक 60 और आएगा. दिस इज आवर नॉट मिनट. सो 60 मल्टीप्लाई बाय 60, देयर विल बी 260 विल बी देयर. देयर विल बी 260s विल बी देयर गाइस. इट इज इन आवर. ओके, तो एक 60 यहां पे बच जाएगा. वन मोर 60 यू विल हैव हियर. ठीक है, सो वन मोर 60 यू विल हैव हियर. ठीक है बच्चों. So 200 को डिवाइड बाय दिस करोगे, देन यस इजीली यू कैन आंसर कि यू विल गेट आंसर क्लोज टू 4 किलोवाट. आंसर कितना आएगा बच्चों? क्लोज टू 4 किलोवाट. सो दिस इज क्लोज टू 400. इसको डिवाइड करोगे क्लोज टू 200, देन यस इजीली यू कैन अप्रोक्सीमेट आंसर क्लोज टू 4 किलोवाट. ठीक है, बाकी आंसर बहुत क्लोज है. यू नीड टू कैलकुलेट. आप इसको चेक भी कर सकते हो. ठीक है, एग्जैक्ट आंसर यू कैन चेक ऑल्सो. आपको फिर इसको डिवाइड करना पड़ेगा. 8000 डिवाइड बाय 18 5. Okay, then this. Okay, yes. तो आपको इसको चेक भी करना पड़ेगा if you want exact answer. ठीक है, तो initially we missed 160. I think you got the point guys. Initially हमने एक 60 मिस कर दिया था, and then if you will use that 60 guys, you will get answer, exact answer option C. चलिए let's move to next question. 34 is the next question guys in front of us. So there is a Carnot refrigerator requires 1.5 ton, 1.5 kilowatt per ton. So Carnot engine which require 1.5 kilowatt per ton. तो 1.5 is the work required per ton of the refrigeration. So आपका COP कितना हो जाएगा बच्चों? COP of a Carnot refrigerator कितना हो जाएगा? It will be refrigeration effect produced, which is 1 ton, divided by work required, which is 1.5 kilowatt. So this is 3.5 divided by 1.5. 3.5 divided by 1.5, guys. COP will be the whatever refrigeration effect you are getting. So the refrigeration effect you are getting is 1 ton, and you know 1 ton equal to 3.5 kilowatt. So 3.5 divided by 1.5 kilowatt. Okay, so answer will come out more than 2, but there are two options with more than 2. तो इन दोनों में से कौन सा होगा बच्चों? That you need to check. You can write it as 35 by 15. तो डिवाइड करके देख लो, 35 को 15 से डिवाइड करो, सो 15 जाएगा आपका किस पे? Yes, it is 3.5 by 1.5. Yes, so it will go on 2, so 30 50, so it will go on 3. So answer will be option B. ऑप्शन बी क्या हो जाएगा बच्चों? दिस इज द राइट आंसर फॉर दिस क्वेश्चन. ठीक है, ऑप्शन बी विल बी द राइट आंसर फॉर दिस क्वेश्चन. वेरी गुड. यस श्रीपल्ली, वेरी गुड गाइस. सो बहुत आसान क्वेश्चन था ये. आई होप इट इज वेरी क्लियर टू ऑल ऑफ यू. लेट्स मूव टू नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 35. So for a heat engine operating on the Carnot cycle, the work output is 1/4 of the heat transfer to the sink. वर्क आउटपुट इज 1/4. वर्क आउटपुट कितना है बच्चों? W out. W out is 1/4 ऑफ द रिजेक्शन. W इक्वल टू 1/4 ऑफ रिजेक्शन. मतलब कितना वर्क आपको मिल रहा है? W इक्वल टू 1/4 ऑफ द रिजेक्शन. एफिशिएंसी आपसे पूछ रहा है. एफिशिएंसी क्या होती है बच्चों? एफिशिएंसी इज W net डिवाइड बाय हीट सप्लाइड. ओके, W net कितना है? 1/4 ऑफ Q2. सो इट इज 1/4 ऑफ Q2. 1/4 ऑफ Q2. ओके, सप्लाइड कितना होता है बच्चों? सप्लाइड इज इक्वल टू W प्लस Q2. यस और नो? हीट सप्लाइड कितना होता है? W प्लस Q2. व्हाट हाउ मच हीट यू आर सप्लाइंग? W प्लस Q2. ओके, चलिए. सो दिस इज 0.25 Q2 divided by Q2 plus W. W is 0.25. So this I can write it as 1.25 Q2. This will be cancelled out. So the efficiency will be 1/5. It means 20%. The efficiency will be 20%. Option A क्या हो जाएगा? Is the right answer for this question. Okay, option A is the right answer. Bidrohi spreading love here. चलिए, good. श्रीपल्ली, बच्चे पढ़ाई पे ध्यान दो. विद्रोही, concentrate here if you want to crack any kind of examination. For a heat engine operating on the Carnot cycle, the heat work output is 1/4. So I think this is very clear. Let's move to next question, question number 36. In a heat engine operates between a source temperature this, sink temperature this, what will be the least rate of heat rejection? अरे भाई, least heat rejection बोल दे, maximum work output बोल दे, both means same. It means you will get least heat rejection if the engine is operating reversibly. तो reversibly heat rejection per kilowatt, what will be the net heat rejection per kilowatt net output? तो पहले तो आप maximum efficiency निकालो बच्चों. efficiency heat engine reversible कितना हो जाएगा? दिस विल बी 1 minus T lower. T lower कितना होगा? दिस विल बी 253 by T higher. 606 है, so this is 606. 273 करोगे तो इट विल बी 879. 879. So this is heat engine maximum efficiency, and this is equal to what guys? कितना होता है? W net divided by heat supplied. Okay, इसको आप लिख सकते हो least heat rejection per of the heat rejection per kilowatt net output. Per kilowatt net output. So if this is 1, this is 1, so this is heat supplied. Okay, so this is 1 by supplied को क्या लिख सकता हूं मैं? This I can write it as rejection plus W. Again, so this I can write it as rejection plus 1. Rejection plus 1. Yes or no guys? So only you need to solve this. आपको इसको solve करना पड़ेगा. 1 by rejection plus 1, that is equal to 1 minus 253 by 879. Okay, or from this you can write it as rejection, q rejection plus 1, that is equal to 1 by 1 minus 253 by 879. ये सुनो गाइस, तो पहले इसको सोल्व करते हैं, इसको सोल्व कर लेते हैं. 879 है and this is 253, so this will be 6, this will be 2, this will be 6. So 879 divided by 626. So the rejection will be 879 by 626 minus 1. So 879 minus 626 कितना जाएगा? 352. So you will get 253 divided by 626. 253 divided by 626. So what you are getting, guys? 253 by 626. Yes, बिल्कुल आप अप्रोक्सीमेट भी कर सकते हो. देखो यहां से इफ यू विल ऑब्जर्व द ऑप्शन, अगर आप ऑप्शन ऑब्जर्व करोगे, ये क्या है बच्चों? दिस इज अप्रोक्सीमेटली 1.5 टाइम्स. इसका 1.5 टाइम्स है 250. 250 का एग्जैक्ट 1.5 टाइम्स क्या होगा? 650. बट यू आर हैविंग क्लोज टू दैट. But other options, they are not matching. They are very, like, there is a huge difference. So exactly you can answer option C is the right answer, because this will be very close to 1.5. Okay. अच्छा, ये रिजेक्शन है ना, रिजेक्शन. अच्छा, लेट मी चेक, अगर यहाँ पे कुछ रिवर्स ना हो जाए. ये होना चाहिए था 626 by 253. Let me check it again, because this is not right. This is not right. The answer will be this is 1 by 1.5, 1 by 1.5. So it will be close to, I think this will be close to this, guys. ये इतना होना चाहिए कुछ. This will be close to this. B होना चाहिए बच्चों, because this factor we are getting, this is not possible, this is not there. ठीक है, तो ये इसका आधे से भी कम है. So I think this is less than 0.5 होना चाहिए बच्चों, less than 0.5. Okay, the answer will be less than 0.5. So C is not right. I think let me check it again, so that we will be able to again check the calculation part. Calculation part को हम check करें. C is not right, because this is 253 by 626. 255 by 326. So this will come out approximately 1 by 1.5. Okay. So I think this will be close to less than that. ठीक है, तो the given answer is option A, and you also need to check. C is not right. Option A is the right answer. For question number 36, option A is right, guys. Question number 36, option A is right. I don't know where you are making the mistake. Let's again check. Heat engine efficiency 1 minus T lower by T higher. So the T lower is minus 20. So it will be 253 by 606. 606 plus 273. So it will be 879. ठीक है, इसको सोल्व करोगे, this will be W net by heat supplied, and this W net we can write it as 1 by heat supplied. Okay, and this 1 by heat supplied, this is 1 by heat supplied. This heat supplied you can write it as rejection plus W. Rejection is, you want to find out, W is 1. So 1 by QR plus 1, that is equal to 1 minus 253 by 879. So QR plus 1, if you will take it this side, so this will be 1 by this. Yes. So the answer is A. A is the right answer, guys. Please check. Option A is the right answer. रितेश का आंसर अब सही आया है. Guys, please check your calculation part. Option A is right, not C. Shripali, you also need to check. Option A is the right answer, not C. Let's move to next question, question number 37. Two reversible heat engine operating between this and this reject heat thermal reservoirs, while the second engine receives heat from the thermal reservoir T2 rejects heat. The efficiency of both the engines are equal. दोनों का efficiency जब same होता है, मैंने क्या बताया था बच्चों, अगर efficiency of one equal to efficiency of two, तो क्या होता है, efficiency same होता है, तो intermediate temperature क्या होता है बच्चों, this is mean, geometric mean of what, T1 and T3. So this will be 1200 multiplied by 300. So it will be under root 36 into 10 की power 4. So it will be 6 into 10 की power 2. So it will be 600 Kelvin. ओके, ऑप्शन सी इज द राइट आंसर. ऑप्शन सी क्या हो जाएगा बच्चों? दिस इज द राइट आंसर फॉर दिस क्वेश्चन. लेट्स मूव टू नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 38. So a perfect gas at 27 degrees Celsius was heated until its volume was doubled using the following processes. तो परफेक्ट गैस है, उसका वॉल्यूम डबल कर रहे हो. सो इफ यू ड्रॉ इट हियर द पीवी डायग्राम, सो दिस इज प्रेशर वर्सेस वॉल्यूम डायग्राम. So this is the initial state. This is the initial state. Suppose volume is V1, and suppose this is the final state where the volume is 2V1. You are doubling the volume. Okay. अब volume को क्या कर रहे हो? Double कर रहे हो. These are the different processes, guys, which are there. Constant pressure. So suppose this is first process, constant pressure, something like this. This is constant pressure process, pressure constant. This is isothermal, temperature constant. Third one is isentropic. PV की power gamma equal to constant. So in all the three cases, the final volume is twice of the initial volume. Which one of the following is correct sequence in the order of decreasing the temperature? तो इसको आप you can draw this on TS diagram also. आप इसको TS diagram पे भी draw कर सकते हो. This you can draw it on TS diagram. Okay. So TS diagram पे for constant pressure you will have a process something like this. This is 1 to 2 constant pressure. Okay, constant pressure line. This is pressure constant. Okay, pressure constant 1 to 2. This is your isentropic 1 to 2 isentropic expansion हो रहा है ना. In isentropic, you know, reversible adiabatic process, whatever work we get work on the expense of internal energy. So the work, because you are carrying out the expansion, and if you are carrying out the expansion means boundaries of a closed system are expanding, means you are going to get the positive work. And in a reversible adiabatic process, guys, if you are getting positive work, there will be decrease in internal energy, so the temperature will decrease. You can ask me, sir, why you are showing reversible adiabatic downward? It may be upward also, but this will be downward only. But constant pressure will be something like this. In constant pressure, if you are expanding the gas, the temperature will increase. Constant pressure में temperature क्या करेगा बच्चों? बढ़ेगा. But in isentropic, temperature will decrease. Okay, you can observe it here. In a constant pressure process, V by T equal to constant. In a constant pressure process, V by T equal to constant means V1 by T1, that is equal to V2 by T2. Okay, or you can write it here, V2 by V1, that is equal to T2 by T1. V2 by V1 equal to T2 by T1. As V2 is greater than V1, so in a constant pressure process, T2 will be greater than T1. That's why constant pressure process I'm showing something like this. Isentropic process I'm showing like this. Why? Because dQ equal to du plus dW. This is 0 in a reversible adiabatic process. So if you are getting the work, W equal to minus du. So if you are getting the positive work, the du will be decreased. It will be negative. Internal energy will decrease, so temperature will decrease in a reversible adiabatic process. Okay. Now there is third process, which is isothermal. This is isothermal 1 to 2. So I think this is the right expression to show these processes on TS diagram. This is isentropic. This is constant temperature, this is constant pressure. So what is the right order, guys? In which case he is asking you the temperature in the correct order of increasing value. तो सबसे ज्यादा टेम्परेचर किसमें बच्चों? प्रेशर में there is a सबसे high temperature, so it will be 1, and then it will be 2, it will be 3. So 3 to 1 means option C क्या हो जाएगा? It's the right answer. You will get minimum temperature in isentropic. Temperature will remain same in isothermal. Temperature will increase in constant pressure. So option C, 3 to 1 is the right answer, because he is asking you to arrange them in a order of increasing temperature. Guys. अच्छा क्वेश्चन है, इंटरेस्टिंग क्वेश्चन है. Yes or no, guys? Very good question. अभी अगर आप इसको इस कंसेप्ट से नहीं करना चाहते अगर, तो आपको क्या करना पड़ेगा? Then you need to solve. आप इसको सोल्व भी कर सकते हो, ऐसे सोल्व करना चाहो तो सोल्व कर सकते हो. देखो, इसमें तो टेम्परेचर, आइसोथर्मल में तो टेम्परेचर सेम रहेगा. आइसोथर्मल में टेम्परेचर क्या रहेगा? सेम रहेगा. टेम्परेचर सेम. ठीक है. कांस्टेंट प्रेशर में निकाल लो, T2 इक्वल टू 2 टाइम्स ऑफ T1. कांस्टेंट प्रेशर में, इन कांस्टेंट प्रेशर because V1 by T1 equal to V2 by T2. So T2 will be T1 into V by 2. So 2 times of T1. So 2 into 300. इसमें हो जाएगा 600 Kelvin. Constant pressure 600 Kelvin. Isothermal 300 Kelvin. Adiabatic भी निकालो यार अगर निकालना चाह रहे हो. Otherwise it is better to go with that approach. T2 by T1 that is equal to V1 by V2 की पावर गामा -1. ओके तो आप चाहो तो इससे भी आप निकाल सकते हो. इट विल बी 1 by 2 की पावर 0.4. सही है. 1 by 2 पावर 1 by 4. तो आप इससे भी आप निकाल सकते हो. यू कैन ट्राई सॉल्विंग विद दिस ऑल्सो. ओके चलिए. सो T2 विल बी 300 into 0.5 power 0.4. चलिए, let's move to next question. I think this is question number 39. So there is a heat engine with 30% efficiency drives a refrigerator COP5. What would be the net heat input to the engine for each megawatt of heat removed by the refrigerator? तो engine का efficiency, what is the engine efficiency guys? It is 30% means 0.3. It is nothing but 1 minus T lower by T higher. So this is equal to what guys? किसके equal है? Drive से refrigerator. ये क्या करता है? Refrigerator को drive करता है, which is having COP5. ठीक है? COP of refrigerator is what? 5. अच्छा ये reversible engine नहीं है. The heat engine with 30% efficiency drives. So this is not a reversible engine. The engine efficiency is 30%. So this is equal to W by heat supplied. So you can write W equal to 0.3 heat supplied. W equal to 0.3 heat supplied. Okay. Now he has given you the COP. COP of refrigerator is 5. So 5 equal to refrigeration effect divided by W in. Refrigeration effect कितना है बच्चों? 1 megawatt. For each megawatt removed, so the refrigeration effect is 1000 या 1000 kilojoule. So this is the refrigeration effect, 1000 kilowatt, and W in is what? 0.3 heat supplied. So how much heat supplied? How much heat input you required for 1 megawatt of the heat removed? So heat supplied equal to 1000 into 10 divided by 5 into 3. So इसको मैंने 3 लिख दिया, ऊपर 10 लिख दिया. So you will get this. So this is 200 divided by 3. So it will be 2000 divided by 3. 2000 divided by 3. So the answer will be 666.67. Option C क्या हो जाएगा? This is the right answer for this question. Okay. Option C will be the right answer guys. Please check. Option C क्या हो जाएगा? This is the right answer for this question. Yes guys, is that fine? Very good Amir. Let's move to next question. Question number 40. In a vapor compression refrigeration system, the refrigeration capacity is this. Heat rejection factor is this. This is heat rejection factor. Heat rejection by heat supplied. This is given to you 1.2. So the rejection is 1.2 times of the heat supplied. Rejection is 1.2 of the heat supplied. So rejection minus supplied. Rejection minus supplied. This is what? This is W in. So W in is what? W in कितना हो जाएगा बच्चों? W in will be 0.2 of the heat supplied. W in will be 0.2 of the heat supplied. Okay. What will be the COP of the heat rejected? What will respectively be the heat rejected and COP? आपसे rejection पूछ रहा है and he is asking you the COP also. Rejection and COP. Okay. So heat supplied कितना है बच्चों? Heat supplied is 2100. So 0.2 into 2100. So this is rejection. Heat rejection. Let me again check guys. So rejection is 1.2 of the heat supply, 1.2 of the heat supplied. So rejection minus heat supplied. Rejection because supplied plus W in that is rejection. So rejection minus heat supplied, that will be what? 0.2. That is W in is 0.2 of the heat supplied. ठीक है? 0.2 of the heat supplied. और हीट सप्लाइड कितना है बच्चों, रेफ्रिजरेशन कैपेसिटी 2100 किलो जूल पर मिनट, ठीक है, 2100 किलो जूल पर मिनट, सही है। सीओपी भी निकालते हैं, सीओपी, सो सीओपी इक्वल टू refrigeration effect means heat supplied divided by W in, heat supplied by W in, and W in you can write it as, W in को आप लिख सकते हो rejection minus supplied, because for any refrigerator supplied plus W in that is equal to rejection, so W in equal to rejection minus supplied, okay, रिजेक्शन माइनस सप्लाइड, तो यहां से आप कुछ बना सकते हो इसको, दिस इज क्यू आर बाय क्यू सप्लाइड माइनस वन, क्यू आर बाय क्यू सप्लाइड माइनस वन, ओके, एंड दिस रेशियो इज गिवन टू अस, ये रेशियो अपने को दिया है बच्चों, दिस इज रिजेक्शन बाय सप्लाइड, सो दिस इज 1 by 2 minus 1, so this is 1 by 0.2, so the COP will be 5, COP will be 5 in this case, okay, so COP is 5, COP 5 आ गया है, then you can easily match it here, यहाँ पे आप COP को मैच कर लो, so COP we obtained 5 and 5 equal to the refrigeration effect produced divided by W in, तो W in कितना हो जाएगा बच्चों, W in will be 2100 divided by 5, so it will be 4, it will be, yes 4 पे जाएगा, 5 4, it will be 1020 किलो जूल पर मिनट, and rejection will be what guys, he is asking you COP also, rejection also, so rejection is heat supplied plus W supplied कितना है 2100, rejection is this, so the heat supplied will be 2520 kilojoule per minute, 2520 kilojoule per minute, so the right answer is option B, option B क्या हो जाएगा, this is the right answer, heat rejection is 2520, rejection is 2520 and the COP is 5. Yes guys, lots of PSUs, there is a hope actually this year, because you know after corona, like in last 2 years very less number of PSUs recruited, last year there was very less jobs, so this year yes you need to be hopeful, there are very good chances, and yes lots of jobs we can expect in this coming year, okay, and that idea we can have from the campus placements also. This year campus placements are comparatively good in most of the IITs, most of the NITs, okay, and if campus placements are good, you can discuss with your friends guys who are actually studying in any of the IIT or IIT or NIT, you will get the idea. If private companies, some of the PSUs, if they are recruiting good number of students, it means there will be some good opportunities in government sector also, because all are linked, okay, government job, private job, they are linked. Obviously lots of PSUs they conduct their own examination, PSUs बहुत अलग examination conduct करते हैं बच्चों, I mentioned many time I mentioned GATE is a kind of unique examination, GATE का अलग level है, some student they actually they are sometimes they face difficulty in scoring well in GATE examination and they crack all other PSUs, even ISRO भी qualify कर देते हैं बहुत सारे बच्चे, okay, so GATE is not a right way of checking the IQ level of a student. There are chances कि a student who is not scoring well in GATE examination but he can have a good IQ also, okay, तो GATE में कई बार pressure भी होता है, there is kind of mental pressure also, अपॉर्चुनिटी आती है और बहुत आपको एक्यूरेसी से क्वेश्चन करने पड़ते हैं, लेवल भी उसका थोड़ा हाई होता है, ठीक है, सो इफ यू हैव नॉट स्कोर्ड वेल इन गेट, डोंट वरी, देयर विल बी सम lots of opportunity you are going to get in the PSUs in the coming year, okay, so you need to prepare for government job, okay, बिल्कुल करना चाहिए आपको। चलिए, a reversible heat engine operates between temperature 900 T2 less than 900, similar kind of question, what will be the value of T2 if work output is same, work output same हो जाएगा तो T2 will be geometric mean, sorry arithmetic mean, T2 will be arithmetic mean, work input same है तो T1 कितना है 900 plus 400, जल्दी में मत करना तो गलत हो जाएगा, it will be 13 by 6, तो it will be 650, ऑप्शन सी क्या हो जाएगा, राइट आंसर हो जाएगा। ये क्वेश्चन बहुत आसान है बट इसको आपको जल्दी नहीं करना है, आपको आराम से करना है, देन ओनली यू विल बी एबल टू आंसर करेक्टली दिस पर्टिकुलर क्वेश्चन। बहुत बार हम ऐसा क्वेश्चन कर चुके हैं एंड मेनी टाइम दे आस्क्ड दिस टाइप ऑफ क्वेश्चन। next question guys, question number 42. A Carnot engine operates between 27 degrees Celsius and 327 degrees Celsius. Engine produces this much of the work. What is the entropy generation? What is the entropy generation, guys? This is good question, but easy one. You know, how much is the efficiency, guys? Efficiency of a reversible engine, Carnot engine. Carnot या reversible engine का efficiency कितना होता है बच्चों? This is 1 minus T lower by T higher. So the efficiency is 50%. Efficiency is 50%. So you are producing work 300. So can I write it here? Heat supplied is 600 kilojoule. Yes or no? Because if efficiency 50%, efficiency 50% means 50% you are converting into work, 50% you are rejecting. And if this is the heat supplied, then entropy generation, entropy change during of the source, actually entropy change during heat addition. Heat addition में entropy change क्या होगा बच्चों? अगर मैं सोर्स के लिए लिखूंगा तो it is going to decrease. And for system, मान लीजिए इसको मैं heat addition के लिए लिखता हूँ system के लिए. So system के लिए this is heat addition, so it will be positive. It will be 600 divided by the temperature of the system source at high temperature. So it is 600. So it will be 1 kilojoule per Kelvin. So this is the entropy generation. Option of entropy change. This is the right answer. Option B क्या हो जाएगा? This is the right answer, guys. ठीक है? Because entropy change for any reversible process, entropy change of for the system will be same as compared to the entropy change of the surrounding. Okay, entropy change of the source, because in reversible process, whatever is the entropy change of the surrounding, that is the same entropy change of the system, because entropy generation is what? Entropy generation is zero in any reversible process. Carnot engine की बात कर रहा है तो Carnot engine के लिए entropy generation will be zero. Option B ठीक होगा बच्चों, please check. For question number 42, option B is right. Let me check also. Yes, option B is right, guys. Note C. I don't know where you are making the mistake. Option C is wrong. Option B is the right answer. ठीक है? Let's move to next. 43. Reversed Carnot cycle working as a heat pump, COP7. What is the ratio of the minimum to maximum absolute temperature? COP कितना है? 7 है. So this I can write it as T higher by T higher minus T lower. Yes or no? So this 7 equal to 1 by 1 minus T lower by T higher. So 1 minus T lower by T higher equal to 1 by 7. So T lower by T higher, that is equal to 1 minus 1 by 7. So this is equal to 6 by 7. T lower by T higher. तो यही तो निकालना था अपने को. तो आंसर क्या हो जाएगा? ऑप्शन सी. ऑप्शन सी इज द राइट आंसर फॉर दिस क्वेश्चन. द रेशियो ऑफ द टी लोअर बाय टी हायर, दैट इज इक्वल टू 6 by 7. ऑप्शन सी इज द राइट आंसर फॉर दिस क्वेश्चन, गाइस. वेरी गुड, अमीर. Let us move to next question. Question number 47. 44, I think. 44. A Carnot engine has a COP6. Carnot refrigerator has a COP6. What is the ratio of the lower to higher? अभी lower to higher पूछ रहा है. अच्छा, तो सेम ही हो जाएगा. सेम क्वेश्चन है, सिमिलर काइंड ऑफ क्वेश्चन. अच्छा, ये हीट पंप था. In year 2005 they asked these kind of questions. 6 में ये पूछ लिया. तो COP रेफ्रिजरेटर का क्या होता है बच्चों? Refrigerator, it is T lower by T higher minus T lower. So it will be 6 by 1 by T higher by T lower minus 1. So T higher by T lower minus 1, that is equal to 1 by 6. So from this T higher by T lower, that is equal to 7 by 6. Okay, but आपको क्या पूछ रहा है? Lower to the higher. So T lower by T higher, again you will get 6 by 7. Again you are going to get 6 by 7. Option C is the right answer. ठीक है? Very good, Ritesh. Option C, 6 by 7 is the right answer. Let's move to next question. Question number 45. A heat pump is used to heat a house in the winter and then reverse to cool the house in summer. The inside temperature of the house is to be maintained at this. So this is what? Outside temperature कितना है? 5 है ना? So this is actually working as a heat pump. So high temperature 20 degrees Celsius, low temperature 5 degrees Celsius. The heat transfer from the room. So means whatever heat the room is losing, whatever heat the room is losing, the same heat you need to supply to maintain the temperature 20 degrees Celsius. To maintain the temperature of the room more than the atmospheric temperature, the same amount of heat you need to supply. In ideal case, the heat which you need to supply will be equal to what? In steady state condition, the whatever heat is losing from the room, the same amount of heat you need to supply. So heat supplied in this case is 7.9 kilowatt. 7.9 kilowatt is a heat supplied. Okay, आपसे मिनिमम पावर आउटपुट पूछ रहा है. So you know COP maximum minimum पूछ रहा है. Minimum power output, it means this heat pump, because this is a heat pump is operating on a reversible cycle. So COP maximum of a heat pump या reversible of a heat pump या Carnot efficiency of a Carnot COP of a heat pump is nothing but T higher by T higher minus T lower. Higher कितना है? 20 है, so it will be 293 and higher minus lower it will be 15. ठीक है, so इसको आप इक्वेट कर सकते हो. This you can equate it with the 7.9 divided by heat supplied working. So the W in equal to 7.9 divided by 253 into में 15. ठीक है, सही है सब कुछ. W in is this. हाँ सही है. Let me check the units also. 7.9 kilowatt and W in is asking you in watt. W in आपसे किस में पूछ रहा है? वाट में पूछ रहा है. तो इसको हम क्या कर देते हैं? Let me multiply here with 1000. He is asking you the answer in watt. आपसे आंसर किस में पूछ रहा है? वाट में. So this 7.9 you need to convert in what? Watts. Then only you will be able to get the right answer. So W in equal to ये कितना है बच्चों? This is close to 15 multiply by 8. 15 multiply by 8 है ना. तो इसको अप्रोक्सीमेट कर सकते हैं हम. इसको अगर मैं 300 मानता हूं, इफ आई अज्यूम दिस इज क्लोज टू 300, सो ये कट जाएगा. इसको मैं लिख सकता हूं 5, तो 50 हो जाएगा. 50 को मैं 8 से मल्टीप्लाई करूंगा. इफ आई विल मल्टीप्लाई 50 विद 8 क्लोज टू 8, आई विल गेट आंसर क्लोज टू 400. बट 400 में तो दो हैं. अब इन दोनों में से डिसाइड करना पड़ेगा बच्चों. 405 या 425, बोथ आर वेरी क्लोज. बोथ आर वेरी क्लोज है ना. तो अप्रोक्सीमेट तो कर सकते हैं यहाँ पे. इसको क्लोज टू 400 तो अप्रोक्सीमेट कर सकते हैं, बट एग्जैक्ट आंसर यू नीड टू कैलकुलेट. ठीक है, तो कुछ ऐसा कर लेते हैं. इसमें 79 कर देते हैं यहाँ पे. ठीक है, और यहां कर देता हूं मैं 15, यहां कर देता हूं मैं 100, और ये आपका 293. इसको देखो, अगर ये जाता है एग्जैक्ट, अगर जाएगा तो फिर अपना फायदा हो जाएगा. तो देखते हैं 79 को 3 पे भेज के, 4 पे तो नहीं जाएगा. 4 पे भी जा सकता है या नहीं जा सकता? चलो चेक करते हैं. नहीं, तो 3 पे भेजते हैं. तो 79 को 3 पे भेजेंगे तो 7 आ जाएगा. ये आ जाएगा 23. तो कुछ फायदा होगा नहीं वैसे इससे, है ना. ज्यादा फायदा होगा नहीं. यू नीड टू चेक. आपको कैलकुलेट करना ही पड़ेगा. ठीक है, चलो देखो इसमें क्या आंसर आ रहा है बच्चों. व्हाट आंसर यू आर गेटिंग? दिस इज क्वेश्चन नंबर 45. 45 क्वेश्चन था. प्लीज चेक व्हाट आंसर यू आर गेटिंग. ठीक है, what answer you are getting guys for this question? Option B is right. Option B सही है बच्चों. Option B 405 is the right answer. 405 watt is the right answer. Yes, very good, thank you. Let's move to next question. ये क्वेश्चन कौन सा था हमारा? 45 405. चलिए सही है. So this is question number 46. There is a heat source H1 supplies this amount of heat at temperature 300. Another heat source H2 supplies this much of the heat at 100 degrees Celsius. Which one of the following statement is correct if the surrounding temperature is 27 degrees Celsius? तो ये थोड़ा अच्छा क्वेश्चन है. देखते हैं, इसको पढ़ते हैं. थोड़ा इसको कम करते हैं. Yes. So there are two heat source. There are two heat source. First heat source supplying this much of the heat. अभी इसमें इंटरेस्टिंग चीज क्या है बच्चों? Both are supplying same amount of heat. तो ये इजी कर दिया उसने हमारे लिए. Both are supplying same amount of heat. अच्छा, same amount है या डिफरेंट है? हाँ, 6000. अच्छा, अलग है. एक में 6000 है, एक में 60000 है. First heat engine is supplying heat at 6300. Another heat source supplying H2 source supplying this much of the heat at 100 degrees Celsius. Surrounding temperature same. ये दोनों के लिए सेम है बच्चों. This is same. आपसे पूछ रहा है विच वन विल हैव मोर एफिशिएंसी, विच वन विल हैव मोर एफिशिएंसी। तो बच्चों इसको सोल्व नहीं करना, आपको इसको सोल्व करने का जरूरत नहीं है। यू नो क्वालिटी ऑफ एनर्जी, quality of heat, or what you can say available energy will be more if it is at high temperature, if it is at high temperature। तो आपसे अगर available energy पूछता, available energy will be different, both the cases available energy will be different, and you cannot answer which one will have more available energy, that you cannot say. Why? Because heat input is different for both the cases. But if you are having a case for which heat input is also given same, then you can say that source for which the temperature is high, that is going to give you more available energy. But this time you cannot say which one is having more available energy. Are you getting, guys? Because both are having different amount of heat input. But heat input is different, rejection is at same temperature, but for heat source 1 it is at higher temperature, heat source 2 is at lower temperature, then definitely the efficiency of first will be more. एफिशिएंसी पहले का क्या होगा बच्चों, ज्यादा होगा, एंड प्रोड्यूस ज्यादा पावर करेगा, ये गलत हो जाएगा बच्चों, ज्यादा पावर प्रोड्यूस करेगा, दैट वी कैन नॉट से। व्हाई? फॉर दैट यू नीड टू चेक। ओके, फॉर यू नीड टू चेक गाइस, उसके लिए आपको चेक करना पड़ेगा। पावर क्या होती है? पावर इज द हीट सप्लाइड माइनस रिजेक्शन। आर यू गेटिंग? उसके लिए हीट सप्लाइड कितना है? 6000। फॉर दिस हीट सप्लाइड इज 60,000। हीट सप्लाइड इज डिफरेंट, तो दिस वी कैन नॉट से। सेकंड हीट सोर्स हैज लोअर एफिशिएंसी, ये हम बिल्कुल कंक्लूड कर सकते हैं। Second heat source will have lower efficiency, guys. Option C, I think option C will be the right answer for this question. Both source have same efficiency, ऐसा नहीं होगा। First heat source will have lower efficiency, ये नहीं होगा। Second heat source will have lower efficiency, that easily we can conclude. For this we cannot make any kind of judgment. ये कब कर सकते हो? फर्स्ट के लिए आउटपुट कितना होगा? पहले का आउटपुट होगा एफिशिएंसी ऑफ 1 इनटू उसका हीट सप्लाइड। दूसरे के लिए आउटपुट कितना होगा? उसका एफिशिएंसी इनटू हीट सप्लाइड। हीट सप्लाइड आर डिफरेंट। तो ये प्रोडक्ट अपने को कैसे पता चलेगा? आप कैसे निकालोगे? फॉर दैट यू नीड टू सोल्व ना, बाय अज्यूमिंग इट एज अ रिवर्सिबल इंजन। आर यू गेटिंग? सो ऑल A, B, D आर wrong, C is the right answer for question number 46. For question number 46, C is the right answer, guys. Please check. अच्छा क्वेश्चन है, सिंपल क्वेश्चन लग रहा था, but it is good. Okay, there are chances, lots of students are going to make some kind of mistake in this kind of question. ठीक है, option C will be the right answer. Let's move to next question, question number 47. Assertion, though heat is added during a polytropic process, gamma greater than n greater than 1, the temperature of the gas decreases during the process. Yes. देखो dq polytropic क्या होता है? dq polytropic is equal to gamma minus n by gamma minus 1 into dw polytropic. dw polytropic. Other than that, we are having one more relation. एक और relation हमारे पास आता है, n minus gamma by n minus 1 into Cv, because this is what? This is Cp polytropic. This is Cp poly. Okay, this is polytropic specific heat into dt. Polytropic specific heat. Okay, and for the temperature range, for the n value greater than 1 less than gamma, you can observe polytropic specific heat is negative. Polytropic specific heat is negative. Polytropic specific heat क्या होता है बच्चों? नेगेटिव होता है. Why? Because even if you will add heat in a polytropic process, there will be decrease in temperature. Polytropic process में decrease temperature क्या हो जाता है? Decrease हो जाता है. Why? Because in polytropic process, work transfer is more than the heat transfer. Work transfer is more than the heat transfer, because the excess work you will get on the expense of decrease in internal energy. Okay, so this is right. ये बिल्कुल सही है. Statement assertion is right. The work done by the system exceeds the heat input. This is also right. In a polytropic process, dq equal to du plus dw. Okay, and as in a polytropic process, when you are supplying heat, this is heat supplied, so this is positive, this is work done, this is also positive, but dw is greater than dq, so आपका इंटरनल एनर्जी क्या करता है? ये नेगेटिव हो जाता है. इंटरनल एनर्जी क्या करता है बच्चों? डिक्रीज करता है. फॉर ए पोलिट्रोपिक प्रोसेस, internal energy decreases, and on the expense of that decrease in internal energy only we get some extra work. Okay, so both are right. Then option A क्या हो जाएगा? This is the right answer. Right answer. Okay, now if someone will ask you, is not this is not a violation, like because you are getting work more than heat, you are getting work more than heat supplied, ये violation नहीं हो जाएगा second law का? This is not a violation guys, because it is not like that कि you are getting work W net more than heat supplied. For a process even you can get work without heat supplying, you know, in a process you can get work even without supplying heat. In an adiabatic process, how we get the work? In adiabatic process, there is no heat addition, there is no heat rejection, but we get the work on the expense of internal energy. So in a process, it is possible. If someone will ask you, in a polytropic process, you are getting work even without even work is more than heat transfer. So ये violation नहीं है. This is not a violation. Why? Because this we are writing for a process. Work transfer more than heat transfer, that is not possible for a cycle. For a cycle, W net will be equal to Q net. ठीक है? Very good. Okay, so I think this is last two question हम solve करते हैं बच्चों. This is 47, 48. हम इसको खत्म करते हैं. 48, 50 ही हो पाएंगे या ज्यादा नहीं हो पाएंगे. Heat pump works on a reverse Carnot cycle. Temperature of the condenser coil is this. Evaporator coil is this. Work output is this. How much is the heat pumped? तो heat pump का COP क्या होता है बच्चों? This is T higher by T higher minus T lower. कितना हो जाएगा? This will be 7, 5. ठीक है, 4 से डिवाइड करेंगे. यस, -23. ओके गाइस, दिस इज -23. सो दिस इज 300 डिवाइड बाय 250. 300 डिवाइड बाय 250. ओके, तो कितना हो जाएगा? इट विल बी COP. ओके, इट इज 3. मैं थोड़ा जल्दी नहीं करता बिकॉज 300 डिवाइड बाय 50, सो इट विल बी 6. COP ऑफ हीट पंप इज 6. सो 6 इक्वल टू work input is 1. How much is the heat supplied? Heat supplied. So heat supplied will be 6 kilowatt. Option C is the right answer, guys. Heat supplied is 6 kilowatt. ठीक है, 6 kilowatt is the heat supplied. ठीक है, अब ये नाइट विजन ऑन हो गया है, तो we are going to solve next two question only. तो मैं चेंज नहीं करूंगा. I think this is comfortable for all of you. तो लास्ट क्वेश्चन है बच्चों 49 and last 50. Guys, if you are connected with us, the PDF you will get on the group. Common group पे आपको PDF मिल जाएगा बच्चों. Common group पे PDF मिल जाएगा. If you will connected with us. Carnot engine operates on this temperature. तो मतलब efficiency कितना है बच्चों? Carnot engine का efficiency कितना है? 1 minus T lower by T higher. तो उसको करोगे तो 600 हो जाएगा. मतलब efficiency कितना है? 50%. Entropy change पूछा. I think this is similar kind of question. Similar kind of question है बच्चों. तो आंसर कितना हो जाएगा? ऑप्शन बी. ऐसा हमने पहले भी सोल्व किया है. दिस इज सिमिलर काइंड ऑफ क्वेश्चन. बाकी के मैं नहीं करूंगा. यू नीड टू ट्राई. कार्नोट इंजन नाइट्रोजन को यूज कर रहा है. वर्किंग फ्लूइड, हीट पंप सप्लाइड इज दिस, एडियाबैटिक एक्सपेंशन इज दिस, रिसीवर टेम्परेचर इज दिस. व्हाट इज द अमाउंट ऑफ हीट रिजेक्शन? भाई कार्नोट इंजन एफिशिएंसी इज इंडिपेंडेंट ऑफ द वर्किंग फ्लूइड. ओके, इंडिपेंडेंट ऑफ द वर्किंग फ्लूइड. तो आपसे क्या पूछ रहा है? इज आस्किंग द अमाउंट ऑफ हीट रिजेक्शन. यू नो गाइस, कार्नोट हीट इंजन heat supplied, so efficiency of any heat engine is 1 minus heat rejection by heat supplied. Rejection by heat supplied. Heat supplied कितना है? 52 kilojoule. Adiabatic expansion ratio is 32/1. 32:1. Okay. Receiver temperature is this. So easily you will be able to find out another temperature. देखो क्या होता है बच्चों? Receiver temperature is this. Adiabatic expansion is this. So you can write it here. T2 by T1 equal to V1 by V2 की power gamma minus 1. Yes or no? So from this, if you will reverse, अगर आप इसको reverse कर देते हैं या ऐसे ही लिखते हैं, T2 by T1 is equal to 1 by 32 power 0.4. This is power 0.4. This you can write it as what guys? This is 1 by 2 की power what? कितना हो जाएगा? 3, 8, 4, 5. So this is 5. This is 2 की power 5. ठीक है. This is 0.4 और 0.4 को आप क्या लिख सकते हो? 0.4 you can write it as 4 by 10. So this you can write it as 2 by 5. This you can write it as 2 by 5. So T2 by T1 equal to 1 by 2 का square, so it will be 4. So T2 equal to T1 by 4. T1 कितना है? This is T2. T2 आपका आ जाएगा, तो T1 आपका आ जाएगा बस. What wise? T1 you will get because we are interested in finding out T1. So T1 will be 4 into 295. Okay, then easily you will get the efficiency. Efficiency of a Carnot heat engine is equal to 1 minus T2 by T1. So this is 1 minus 295 divided by 4 into 295. So this will cancel out. This is 1 minus 1 by 4. So it will be 3 by 4. 3 by 4. 3 by 4 क्या हो जाएगा आपका? Efficiency हो जाएगा बच्चों. And heat supplied is 52. Heat supplied is 50. So the W net by heat supplied. W net by heat supplied. तो अभी आंसर कर सकते हो आप. W net आप निकाल सकते हो. Then rejection also easily you will get. So W net equal to 0.75 into heat supplied, which is 52. Okay. And then if you will want rejection, so rejection कितना हो जाएगा? Rejection will be 0.25 into 52. So 52 divided by 4. 52 divided by 4. I think option B will be the right answer. 52 divided by 4, option B will be the right answer, guys. Option B क्या हो जाएगा for this question? Option B will be the right answer. सही है? 52 divided by 4, option B will be the right answer. So guys, these are the 50 questions for the today's session. Okay, I tried, initially I planned to cover 60 questions, but you know, it is very difficult to cover. So there is another session of Ruchin sir at exact 9 p.m. So I need to end this session, guys. So if you want to join us, if you want to avail this, module, you can contact us. You can go to our website and you will get the complete detail about this module. Okay. Further, for any query, you can talk to our technical team representative. Thank you very much. Have a nice day. Keep preparing and good luck. Have a nice day. Good luck.